Good evening, all. Without any further delay, let me just introduce the chief guest for the day. It is my privilege to introduce the speaker of the day, Dr. Shyam Nair. Dr. Shyam Nair did his master's and PhD from Texas A&M University, USA. He did his BTech from College of Engineering, Trivandrum, Kerala. He is presently working as faculty in the Department of Civil Engineering, IIT Kanpur. He has several reputed publications to his account and is an expert in payment materials and engineering. We are honored to have Dr. Shyam Nair for delivering this session on full-depth reclamation, execution challenges, and quality control. Since we are short of time, without any further delay, I invite Dr. Shyam Nair and all the participants to this program. Over to you, sir. Thank you.
So thank you very much. So good evening, everyone. This is Shyam. So today's presentation, I'll be looking briefly into various challenges that are faced, or some of the challenges rather, that I could come up with, or rather think about as an immediate problem that practitioners might encounter when they are doing construction work, and also some of the techniques that are typically used in quality control of these FDR materials actually. So I will start off my presentation with a broad introduction of FDR as such, because I don't want to get into the details of it, because most of you, I believe, are aware of what exactly FDR is. So I'll just broadly touch upon some of the things that are involved, and then I will get into the core part of the presentation. So this will be around 5 or 6 slides that I have on this particular area. So now when we talk about reconstruction, there are reconstruction or maintenance and rehabilitation, there are multiple ways in which it can be done. So the typical practice is like a building up option, which means that whatever is there, we try to build on top of it. Good example of that would be if you have a problem, you put a structural overlay on it, or any kind of like overlays of that matter. So now the problem in these cases is that some of the distresses that we typically encounter in case of pavements cannot be addressed, especially cases where you have some rutting issues, say base damage is there and base repairs needs to be done. Now those kind of issues cannot be addressed properly when we are doing a build up or a structural overlay kind of an option. Now there are other issues like the elevation of the road, or the reduced level of the road raises above what was there, and you have other problems related to the level differences with gutters, then overhead clearances in case of under bridges and all those things. So those are some of the issues. Now the alternate option that we have is to remove and replace, remove everything that is out there and then build a new one. Again, a good option, but couple of issues that are there, like construction window is pretty long, which means that the road has got to be closed off for a longer period of time. Then a large quantity of virgin materials are required, so the cost obviously is going to be much higher in that particular case. Now, when we deal with the PMGSY roads primarily, or village roads, if I would use that word, these are many a times single point access roads. I mean, you don't have multiple access options for the residents. So closing it for an entirely long period of time may not be a very suitable option in this particular case. Now, the alternate option that is there is to recycle the existing ones, or rather I would call it as build down. Whatever is there in the pavement section, you actually use that and reconstruct your pavement using the exact same materials that is available to you. So this can lead to, again, a lot of benefits, as you can clearly understand. Some of the resources that are required, the quantity of resources required is less. Construction window can be very short because you are going to be adding certain additives into that, which can give immediate strength to the section layers. So the construction window can be small. Then since the new materials that are being used is much less, it's a economically viable option as well. Now, the structural capacity of the road itself can be improved because it's an entirely new section that we are building, and we can customize it depending on our requirements at any given point of time. And on top of all these things, the additional virgin material that is required in terms of surfacing, which is typically what is practiced in case of PMGSY roads. Typically, we give about 1 to 2 inches of overlay BC layer on top of the existing or reconstructed FDR, which will cater the requirements in terms of surface protection and smooth riding comfort as well. So all these things comes out to be advantages of using this recycling option. Now, basically, if you talk about what is happening in there, now let us say in the figure here, what we have is a GSB material. I'm adding cement to that, and I'm trying to compact that into a CTB is an example that I've been using in this case. Virgin materials, the modulus that you get because of while using a GSB material is somewhere of the order of 200 MPAs, whereas once you convert that into an CTB or a stabilized layer, you are looking at numbers in terms of 15 to 1800 megapascals, which means you have a much stronger layer. Advantages: the stronger the layer is, if you look at the picture here, once you have a unstabilized layer, once a vehicle travels on top of it, there is going to be significant deflection because the underlying layer is not very rigid. So because of those deflections, you may end up having fatigue damage in your HMA layers, because every time it's flexing, so horizontal tensile strains accumulate at the bottom of your HMA layer, and the failure is going to be much faster, which actually does not happen once you have a cemented layer, because the surface layer is not going to be flexing very much, and as a result of that, fatigue life of the bituminous layer is improved significantly. Now, the same applies in case of rutting as well, because you have, in this particular case, you have a unstabilized material. So the load that is being transferred by the vehicles is distributed localized fashion, which means possibility of having a subgrade damage is going to be high. Whereas in a stabilized layer, as you can see here, the same load is distributed in a much wider area because of the rigid layer, or rather a semi-rigid layer that you have in between. So the rutting issues can also be addressed by using this recycling technique. Now, in terms of stabilizers, the typical choice in most of these cases that we are dealing with right now is cement. It's not mean that other stabilizers cannot be used. If you look at the table that is given here, what I have on along this horizontal row is the different type of soils that so basically soil classification. And what I have here is the different options that can be used. Let's say if you look at emulsified asphalt, then what you can see is that as you move towards the right on the screen, they are more clay soils, and the one on the left is more like granular. So emulsified asphalt options works very well when the soil that we are dealing with is more of a granular texture. And as you, if you can look at the lime part here, the lime is effective when you have the soil that is more of a clay type. Simple reason is that the clays are required for lime to actually react with, and as a result of that, the strength gain can be achieved. If it is a non-clay material like granular material, the strength enhancement with lime does not work out very good. So how do you do that? You can estimate the utility of a given stabilizer by looking at the PI values of those soils. Say, for example, if the PI is more than 20, then lime can be an effective solution. If it is less than 6, then you can go with something like a emulsified asphalt option. Now, the main point here is that if you look at what is applicable for cement, it is more or less applicable for all granular materials, as well as for certain level of clay content that is present in soil. If the clay content is extremely high, then we may have to switch to a lime option. But in normal soils that we encounter, the PI is not going to be very high. So cement universally becomes a preferred option in this kind of a process. Now, in the case of reconstruction, once we go about in terms of selecting an FDR, the first thing is that to check whether the given road is going to be a good candidate for FDR purpose. That's the first thing that we have to do. Now, more or less, if you look at it broadly, then what you can say is that any road that is meant for reconstruction can be a good candidate. Now, roads that has got seriously damaged and cannot be completely rehabilitated by simple resurfacing, that's a good road that you can select for this option. The distress levels, it's going to be very high. There is going to be areas which has got significant amount of base and subgrade damages, again a good candidate. A road which has got a lot of patching, say for example 15 to 20% of the road is already patched up, which means it already had some level of distress, that can also be selected. Now, if the structural capacity of the pavement is not good enough, then yes, you have to, instead of giving a much thicker section on top, you can actually choose FDR as an option and go ahead and improve the structural capacity of that pavement as well. So in case of exceptions, more or less, one of the things that you have to deal with broadly is whether the road is going to have any kind of drainage issues. Now, the problem with water being present is that it can negatively affect the strength gain process when cement is added, and also it can deteriorate the properties. If the cement has already given it enough strength, the introduction of water can actually cause deterioration of those strength properties. So whatever we do, if we have a drainage problem associated with a given section, it is always better to address those problems first, and then you think about choosing FDR as an option for that particular candidate road. Now, the other thing that needs to be careful about while selecting a road is to see if the road has got some, geotextiles, geogrades, or anything like that, which is already present in the road. If a road has got these geotextiles, then it is ideally not a suitable candidate for FDR. Simple reason is these are textiles or sheets or layers, and what we are doing in this process is to remix the entire material that is there. That includes the bituminous layer, then the paste layer, and the soil as well. So when you are using a reclaimer or something to mix up these three layers, a geotextile layer in between can negatively affect the mixing, proper mixing of these layers. Again, mixing of the in situ layers, mixing of cement with these layers, and also it can cause damage to the machine that we are using. So all because of these, if a pavement section has got a geotextiles or a geogrid in there, it is ideally not a very good candidate for FDR option. Now, in terms of process, I know that you already know about all these things, but just to recollect, we are actually working with existing HMA layer, existing base layer, and a part of the subgrade layer. And the process involves multiple steps or multiple stages. We can rather call it as a train, because it's a continuous process where stabilizer is dispersed first, then it is going to be followed by a spreader that spread out the materials evenly across the width of the pavement. Then recycler along with the additives or chemicals or water comes in, and it actually mixes up the whole materials together and add the required additives and water along with it, followed by a set of compaction approaches, like static compaction, then shift foot rollers, and all those different kind of compaction, which I know that you guys are familiar with that, so I'm not going into the details of that. So a simple pictorial representation of various steps are given. Cement drying is there, water injection, a truck is following that, it's in the front of the machine. Then there's a reclaimer that is running along with it. Then you have pulverization, which the reclaimer does, followed by grading that you have to do, and various levels of compaction. So this is a typical process. Now, starting off into the challenges that are faced in FDR execution. Now, many of these things kind of feel very rudimentary for you, but these are significant enough to affect the timely completion of any given FDR projects. Now, the first thing is that identification of utilities. Now, this is one part that creates problem in practically every construction work that we perform, especially recycling, in situ recycling like FDR. Now, the problem here is that these roads that we are working on has been there for quite a long period of time. And different types of utilities have gone through it, and it has been covered up by the existing surface. So when you look at it from the top, it will be very difficult for us to identify these ones. This could be examples like water lines, then there will be drainage lines, it could be electric and telephone cables, whatever, you can think of all these things. And all of these has got to be relocated before we start the actual FDR work. Simple reason is we are going to use about a 25-ton reclaimer that is going to be standing on top of this, and it is going to be mixing up the road surface altogether, road depth altogether. So all these utilities need to be reallocated before we actually start the construction work. And the real problem is that the data related to what is going where, nobody has any idea about. And if you ask any agencies, then identifying these locations is going to be practically impossible. They don't have any information about what has gone into there. This will include what the different agencies have put in, what household people have put in, connection lines, all those things are going to be there, which need to be identified on site. Now, in a practical sense, if you look at it, if you have horizontal crossings of utilities, then it is very difficult to identify, because once we start off this process, we'll be taking trial patches or trial pits, and longitudinal utilities like water lines or drainage lines or sewer lines, those can be identified easy. But if there is something that is horizontal, then it will be very difficult, and we need to be careful while we are doing the reclaiming process to identify these, and at least even if we have to stop the work, we need to relocate them before it can be completed. Now there are surface utilities as well. If you look at it, manholes are going to be present. There are going to be electric poles, because many a times we might be widening the road as well, along with strengthening it. Say for example, a 3.5 meter road has to be widened to a 5.5 meters. So obviously all the electric lines, electric posts, all of these things that are abutting the existing road section, which many a times, as we see, is going to be very close to the pavement section. So they all need to be relocated, and before the work can be executed. Now, saying that is pretty simple, but removal and realignment, it's a difficult task to do, because in Indian conditions, it's not managed by a single utility agency. Different parties, different people as stakeholders in that. Say, for example, drainage department, then electricity boards, and all those people, different agencies are stakeholders. So interagency coordination becomes a very significant factor. Again, it will happen, but time is of essence, and many a times this can actually delay the progress of the work. Now, along with that, there is end user interest, because the people living here, they are the actual users of the road. Somebody might be having the house in front of it. They don't want to have a water line that is, relayed utility that is placed in front of their house, because if something happens later, if it breaks, then the whole area is going to be, excavated and reconstructed, which is going to be a difficult thing for them. So they might ask you to actually change it from this place to that place. So these kind of stakeholders, let's say if it's a shop owner, then he might have his own preferences in terms of certain things. So we will have to accommodate all these things while we are relocating this. And in fact, bottom line is that this can lead to time extensions and many a case cost overruns, which unfortunately cannot be completely estimated prior to the start of any given project. So only after the work gets awarded, the area has been allocated, then you start looking at this. And this has got to be done as early as possible, because this can take time. And so the process of identifying these utilities has got to be done in the very beginning. So now the other problem that we typically face is that the depth of existing pavement many a times is actually higher than the FDR thickness. Let us say typically what we do in terms of FDR thickness is about 25 centimeters. 20 to 30 centimeters is something that you can reasonably think. Now you might end up having different kind of pavements, existing pavements. If you look at the one on top, there is going to be a very significantly thick bituminous layer on top, and the bottom one has got a very thin layer. Now, thin layer is not much of a problem because we are adding cement to it, whereas a thicker section can be a problematic case. Now, the reason why it becomes problematic is that cement has got less binding with the bituminous materials. Now, the cement gains its strength by reacting or interacting with the soil and the granular materials that are underneath the existing pavement. So, the interaction with cement, interaction with soil, or interaction with granular materials, that gives the strength. Now, if you have a bituminous layer that is almost like, let us say, 30 centimeters thick, and you want to perform an FDR of 25 centimeter on it, you are at best, you are staying within the HMA layer itself in terms of your reclaiming process. So no soil available, no granular material available. So if you use a certain amount of cement, it will not provide you the required strength that you are looking for. So in that case, what you have to do is you may have to come back and mill and remove the surface layers to a certain depth. Let us say, for example, you are trying to construct a 25 centimeter thick FDR layer. Bituminous layer already is 30 centimeters. The best option would be you come back and mill out about 20 centimeters of your, HMA layer and replace that. Take it out of the construction site. So that may be required so that FDR can be effectively done. Now, what this brings around is cost overruns, unprecedented cost overruns, because these mill materials has got to be transported. That has got to be disposed in a proper site, which can also be costly. That space can be kind of like a few kilometers off of the project space. So transportation cost is there. Then time that is required for this milling activities is up and above the time that is allocated for the construction work itself. So this is one problem that is typically encountered in these construction sites. Now the other one is different layer thicknesses. Now, as you know, if you take a 5 kilometer stretch on a village road, you might end up having a small section like half a kilometer which has gone through significant amount of damage, and some agency has come in and actually did a couple of overlays to address this problem. Now you take your samples for your material testing from the section before that, and you end up being in that particular section, then your entire bituminous layer thickness is different, which means that the mix design that you have prepared using the first location sample is not going to be very effective in this particular case. Now, that is one problem in terms of thickness. Now, the other thing is that difference in layer compositions. In Uttar Pradesh, many of the works that we do, one thing that is commonly observed is brick bats. Now, people put brick bat layering on it, and top of that, bituminous layers is actually placed. So because of that, you may end up having brick bats in there. There might be boulders that has been put in the very initial phase of the construction of the road. Then there could be different aggregate sources from which they have collected materials and used it. The soil types can vary with respect to locations. So all these things has got to be identified. And the mix design that you're using has got to be adjusted in one way or the other, so that uniformity is maintained all the way through. Let's say if you have a multiple layer thickness of HMI layer, because of the overlay, you can actually mill out some of those sections and take it out. That can solve your problem to bring it back to the original mix design that we have actually prepared. Or in certain cases, you may end up requiring more than one mix designs as well. So all these things need to be identified as part of the DPR preparation stage itself, so that work can go on smoothly. Now, one of the other problems that we typically face is realignment issues. Now, if you look at many of these old roads, they may have multiple curves. They are not designed to maintain a certain specific speed. So once you are reconstructing, you cannot just go back and do the same thing, because speed limits and the speed requirements have changed. If you want to try to make a 50 or 60 kilometer speed roadway, then of course the realignment of the road and the smoothing of the curves have got to be done, which means that the curves needs to be straightened in many areas. So that brings in its own challenges. There are super elevation issues because the curve, the super elevation is different, then the material configuration or the layer configuration is there different. Then you have center line shifts. If you look at the figure here, the center line itself has changed. Or even in this case, you can see the same thing. Now, all of a sudden, when a center line changes, then what happens is that materials, what are the existing road, depending on which we have made the mix design earlier, is actually falling out of the center line. So which means that those materials needs to be shifted because of the realignment that is happening. Then because of realignment, again, right-of-way issues can happen. Then cut and fills can emerge. Now, realignment brings into a cut section, so all of this has got to be cut and removed, and there might be places where filling has got to be done. But balancing cut and fills many a times becomes a difficult proposition, which is a site-specific concern and has got to be taken care of in the site itself. Possible solutions, problems has got to be identified in the DPR stage itself. You have to foresee what is coming up. After preparing your alignment, you have to revisit the location and make sure that many of these issues that has been addressed here has been taken care of. Now, dosing or shifting of the materials is required, because center line has now shifted. So the existing road has got to be brought back to the center line, and they have to be dispersed again for FDR process. So that requires additional money, then additional efforts. So in certain cases where it is not at all possible, we may have to consider the option of constructing with new materials, say like GSB. Let's say if you are milling out the whole existing road, it is going to be very similar to a GSB material. It has got granular materials in there, it has got fine fractions in there. So instead of moving the whole road itself, you can do the FDR process, or rather it is going to be more like a CTB section, but still very similar in terms of the process. So GSB can be laid in that particular stretch where the realignment has happened, and it can be stabilized again. Now, another problem that you typically encounter is longitudinal grade issues. Longitudinal grade corrections need to be made to maintain the safety aspects, to maintain the speed requirements and all those things. So fresh materials or fill materials needs to be brought up. You have to buy new GSB materials to lay on top of the filled areas. So all those can actually come in case of issues related to longitudinal grade corrections. And this is going to be a significant, if it is there, it's going to be a significant quantity and cost-bearing quantity. So it has got to be accounted for as a part of estimate preparation. Now, the other problem that typically comes across in case of FDR is problems with subgrades. Now, you might encounter soils which has got very high plasticity. That is like as I've discussed earlier, if the plasticity goes about 20 or so, then cement may not be a very good option. So this may not be something that you see all the way through in your pavement section that you reconstruct. Patches, especially if you are working in areas of agricultural areas, say for example rice paddies, the clay content in those soils are going to be quite high when compared to something that is there in a residential area. So those kind of things needs special attention, and again it can be only be addressed in a site specific manner. Now what happens is that when clays are present or high plastic clays are present, they absorb water, and when they absorb water and cement, once it is put along with that, and if you try to mix it, mixing is not going to be uniform, and as a result of that you might have sections which has got very high strength, very low strength. So it will be a mixture of all those things which cannot be upfront predicted. So that problem will always be there, and it has got to be addressed in a site specific manner. Next thing is about organic content. Again, if your agricultural areas, rice paddies, you may end up having soils which has got a very high organic content. Now, if the organic content goes anywhere above 1%, then cement or any kind of stabilizer does not work very well. A good representation of that is given in the figure here. You have the compressive strength and you have the organic content of soils in an increasing fashion in the x-axis. Now, what you see is that as the organic content increases for a given mixed design, the strength properties of that soil actually goes decreasing. So that is one problem we have to keep in mind when we are dealing with organic soils. Now, next problem is not something that is very obvious in every place, but it is always better to check it out. Now, this is a problem related to presence of gypsum or sulfate in your subgrade soils. The problem is that if sulfate is present, that can interact with the additives, that cement that we are using, and it can lead to swelling of those layers after construction, once water becomes available. So now if something like a heave that you are seeing here on the figure happens to your road, it's going to be completely damaged. But again, the good part is that this may not be encountered in all the places. Say if you have an area which has got a lot of rainfall, an arid climate, a lot of rainfall, and the soil is quite porous, pervious, then these can dissolve in water, and over a period of time the sulfate content will be very low. But if you are looking in some clay-rich areas, if that's got to be happen to be a gypsum source that is present, that will still be available in those clays because it is not going to be that porous, so it will still remain on that, and those areas can actually have this kind of a problem. And broadly speaking, generally speaking, if the sulfate levels, if you are looking at it, anything below 3000 milligrams per liter, that is a concentration estimation of sulfates. If it is less than 3000, then there is not going to be much of a problem. Now, one of the other things that you typically encounter is related to shoulders. People have come up and said that shoulders are not required. Well, it actually contributes to the structural strength of the road itself, simply because it can avoid edge crackings. And it will stop the vehicles from going off the road, and as a result of that there is going to be a differential or a cantilever kind of an action on the roads, or rather it is going to be non-uniform kind of loading that is going to happen along the edges, and it can lead to edge crackings. Now the other problem is drainage options. Many a times we work with road sections which are limited by right-of-way availability, and provisions for drainage is many a times ignored because of cost constraints, because of right-of-way issues, and all those things. So you have to make sure that there is no waterlogging in these areas, and also a reasonably good drainage provision is available. Either it is a constructed one like a concrete drains or a brickwork drain, or even an earthen drain that can effectively remove the water from going underneath the pavement section. So once water comes in, then you are going to have that is going to detrimentally affect the stability of these layers and ultimately leading to the failure of your pavement section. So now, last but not least, but challenges is on the administrative side. Now this is related to payments that are made in construction. Now, if you think about this whole process, this is going to be quite expensive in terms of construction materials that is being used. Then the machinery that you are using is going to be hugely expensive as well. So any delay in terms of payment making can actually lead to a huge financial loss to the person who is working, the contractor basically. So if I give you a ballpark number, an ideal set of machineries lying in a site over a period of 1 month can cost the contractor near about 25 to 30 lakhs. That's the loss that is incurring if a machine stays idle in a construction site for 1 month. This is a ballpark number, can go on and off depending on what all are there. So ideally, that is why I have added, along with the train that you have seen earlier, I have added a money track along with that, which means that as the work progresses, the money has also going to go along with it. So then only the work can be a successful one, and otherwise it can lead to issues related to litigations and all those things. So there are cases that we have encountered because of this issue as well. Now, administrative side, there are other things that you have to look around, that is managing your work packages. Now, how much of work has got to be awarded to a given contractor. Now, it should be such that it is going to be cost effective for him, and also it should be something that is manageable. Now, if in Uttar Pradesh, initially what we have done is that a package, every package that is given to one particular contractor was up and around 30 kilometers, not a single stretch, at different adjoining areas, wherein the equipment can be mobilized easily from one side to the other, and overall the work will not get stopped because of movement of this machinery and all those things. So it is still manageable by the contractor. Then evaluation and quality checks, which we will discuss as we go along. These are also quite time consuming. So along with the contractor, the administrative staff and the field engineers, they also have to be proactive in case of getting all these things done. The simple reason is that, see, FDR, if you think about the whole process, you are stabilizing the layer, you are leaving it there for 7 days, you are going to go back there and take a core out of it, do all the strength testing and everything, and only after the results are approved, he can move forward, or even 28 days strength durability test. All of these things are completed. Durability itself takes about nearly about 55 days for completion. So once the road is constructed and completed, only after near about 2 months, the work can be paid off. So any delay further than that is going to be negatively affecting the financial resources of the contractor as well, because he might be continuing with the work as he moves along. So that needs to be taken care of from the administrative standpoint, or timely payment must be ensured in case of this type of a construction. Now, going off from the challenges, some of the challenges that I could think of immediately, some of the steps involved in FDR, like you can broadly divide that into pre-construction, then construction, and post-construction. Again, pre-construction involves evaluation or assessment of the project, then sampling is there, mixed design is there. That all comes in as a part of the pre-construction. When you're doing construction, the actual steps, the pulverization, then stabilization, inclusion of the additives, then compaction and grading, curing, and all those things comes in the construction phase. And end of the day, there is this post-construction quality checks that is being performed. Hello? Oops. Just 1 second, my computer got hung up. Is the screen visible?
Yes, yes.
Yeah, perfectly.
Sorry, my computer just got hung up, so I was just putting it back. So now moving on to quality assurance and quality control and quality assurance in a construction. Now, quality control, again, broadly speaking, it's a generic definition, not exactly from any particular book or anything. Now, quality control, if you look at it, it's something that is being done by the contractor or the manufacturer himself in presence of the agencies that are monitoring it, which is primarily done at the time of construction to ensure that the client is actually getting a good quality product. Now, in terms of acceptance, that is what a client actually looks at in terms of the criteria that are required for to ensure the quality. He is looking at those things, and the owner is ensuring that, okay, he is getting a good product. Now, quality assurance testing is something that is meant for future, which is to ensure that a long-term product, quality product is being obtained for the satisfactory performance. That is what a quality assurance testing essentially broadly means. Now, speaking about this, what you can say is that even though these are kind of things that we typically do, like quality control testing done during time of construction, then assurance or third-party checking done much later stage, broadly speaking, quality means you have to, everything that needs to be done to ensure the quality, the durability, or the performance, that falls under this quality control steps. Now, it does not mean that only during construction the quality control steps needs to be maintained. If there is something that is there in the pre-construction stage which can actually affect the outcome of a project, then that also has got to be monitored. Quality of those work has got to be monitored. What is this? Now, in case of FDR, if I look at it, then broadly you can see that quality control can be divided into 3 stages. One is during DPR preparation, then before construction, then during construction. Now the question is, why these 3 different stages? Why is it different? How is it different? If you compare that FDR with some of the conventional approach that we follow, say for example BMDC roadwork, or even a CTB layer as a subgrade or a base layer. Now these are all we are working with materials that we have a complete control on. As in, like, these are typical mixes, which has got very less variability. You'll be buying the material from a particular source. You have checked it all up. Then even if it comes to the site, you can actually check it randomly and make sure that you are getting the exact same material that you have ordered for. Now, the source of aggregate, if it is not good, you can control that binder, the additive that you're using. That also you can control that depending upon what you need. You have perfect control of that. Now, the soil conditions that are existing, when you are building up, before the start of the road work, the subgrades is easily accessible. So anything that needs to be done on that, say for example, if you want to put some boro soil in it, you want to change some moisture content while you're compact, it's all possible. Now, if you look at FDR on the other hand, the mixed proportions can vary completely. It is not homogeneous. So because of that, 100% in-situ material is what we are using. The existing whatever is there in the road, we are bound to use that. So all these different things, like some areas might be having brick beds, some would have different aggregate sizes, some will have different aggregate source, soil type underneath can also vary. So all these things affect the quality of the product that you are getting. The layer configuration, the thickness of individual layers, that also can vary depending on the maintenance and rehabilitation practices that has been adopted on that given section. Then NMCs, the moisture content, natural moisture content of the soil can also vary. If you're working in an environment where right after rainfall event, then of course the in-situ moisture content is going to be much higher when compared to what you have done as a testing process. So that also needs to be checked in, which is also a variability that is being brought in into the construction. Then in certain cases, fresh materials may also need to be added upon so that the work can be completed. Is happening here. So if you look at the quality control steps, so if you look at the quality control steps, you can broadly divide that into 3 stages: DPR stage, before construction stage, and during construction. Again, we will discuss some of these things in the following slides. DPR stage involves identifying the depth of recycling that is required, the gradation that is coming out, then the plasticity of the soils, the in-situ strength properties, development of your mixed designs, then the type of cement that needs to be used. All these things comes in as a part of the DPR stage preparation. And in terms of right before construction, the cement quality needs to be checked, additives checked, then water, the kind of quality of water that you are using, that also needs to be checked. Then comes in the third part, which is during construction. Now, the gradation that you are getting after pulverization, is it meeting the requirements that are set aside by the mixed design process? That is one thing. Moisture content, is it in concurrence with what has been asked for? Then the quality of quantity of cement spread that is happening? Is it according to what is being recommended? Uniformity of mixing, is it really achieved? All these things comes in as a part of your quality control test. Now, ultimately, you have to remember that it is all going to be done based on strength and durability properties. Now, the problem here is that why all these things that can be done in situ becomes, or at the time of construction, becomes very critical, is that the monitoring criteria, which is the compressive strength, can only be obtained after 7 days of curing, which means that the work has already completed. And now there is no, if the work is not done properly, then you are not going to meet the specific strength requirements, which means that all these tests that I have mentioned earlier, pulverization, moisture content, quantity of cement, uniformity, all these things are actually proxy, or in a way we are trying to ensure that this mix is following the mix design, and there is a good chance that the compressive strength, the strength requirements of that mix will actually be met. So that is the significance of doing all these construction checks in case of an FDR.
Sir, use the next button is there.
It's
the
not
bottom
working.
next button is there. You can use.
It's
no, sir,
not
there
working.
where you are.
Yeah, here.
Yeah, last
okay.
one. Yeah.
Okay, I got it. Thank you. So in terms of DPR stage, depth of recycling. Now, recycling depth or thickness of the FDR that is required is going to be dependent on multiple factors, like design traffic is a criteria, then extent of distress that is there, which is contributing to the structural value of the pavement, requirement of the pavement, then the crust thickness that is there, subgrade types, all these has to be identified as a part of field investigation. Now, the requirements in terms of the depth of recycling, that can change if one of the things change. Let us say if the subgrade type change, then you may have to add a slightly higher or thicker section so that the structural requirements are met. So the sampling has got to be effective so that it captures all these differences, and these can be accommodated as a part of your mix design process. Now, sampling locations and frequency of sampling, that again becomes critical at this point. So next thing is subgrade investigation. Now, why is subgrade investigation essential in terms of quality, ensuring quality? Because this can actually seriously influence the fatigue life of your pavement section. Now, if you look at the typical test that is conducted, these are kind of like soil classification tests we do, then plasticity index testing, Satterberg limits, plasticity index PI value testing is done. Then the in situ CBR properties of the subgrade soil is done, typically by using DCP and correlations established based on criteria in STMs or other specifications. Now, one of the things that you can think of is that, let us say you have a soil pavement that is existing, which has got say around 10 centimeters of boro soil that is present, and underlying soil is of really poor quality. That is why for a low volume road, a 10 centimeter or a 15 centimeter boro soil is actually kept. Now, when you are going 25 or 30 centimeters deep and essentially trying to mix everything up, you're actually utilizing the poor quality soil underneath as well. So what happens is that with the depth, in this case, as the depth increases, the effective modulus that you are going to get after the stabilization is going to keep on decreasing. So you need to account for that as well. So if the modulus is actually decreasing, then effectively what happens is that the horizontal tensile strains on the bottom of your layer actually increases, and as a result of that, the service life of the pavement goes deteriorating once you have this kind of an issue in your section. Now, aggregate gradation for FDR. As you can see in the figure itself, if you look at the gradation requirements set for these larger size fractions, it's quite broad, starting from passing 95 to some of these sections. Say if I take 19 as an example, 19 mm sieve as an example, it can be anywhere from 45, passing 45% to passing 100%, which means if I look at 475, it is also okay to have the stabilized pulverized layer to have 100% passing 4.75. That's also allowed in this particular specification that is given to you for obvious reasons, which I'm not going to discuss much right now. So it's a very broad range. So now what is the problem here? Now, the moment you have such a broad range, anything that falls within that category is accepted. But depending on how much of that material, let us say if you decide as an engineer, you are deciding that, like, I'm not going to use 19 at all, so I'm going to go with 100. But instead, I will use 9.5. Now, it can go anywhere from 35% all the way to 100. So that is a requirement that is being set. Now, when you go from up to 35% is passing, the amount of fines which actually contributes to the strength of this mix changes accordingly. So which means that whatever is being decided in terms of what all kind of materials to be used has got to be accommodated as a part of the mix design process. Now, otherwise, the problem is that if the fines content changes from what is being done in the mix design part versus what is being used in the field, the amount of additives that is required, the moisture level that is required for the compaction and curing, they are all going to be different depending on the amount of fines particle that is there. Now, if that changes, if let us say you have very less fine particles to begin with, cement content that you have estimated by mixed design is 4%. Now, inside, if you remove all the top parts and try to include this and as the fine particles as 100%. Now, all of a sudden, you have made your mixed design with an estimate of around 40% of fines. And now you end up having something that is much higher than that. So all of a sudden, the cement that you are adding is not going to be enough. Now, what happens because of that? Mixed properties, the strength, the durability, everything changes accordingly. You are going to have an inferior quality product at the end of the day. So the ultimate thing is that the gradation and the materials used must be consistent with what has got to be, what is being done as a part of the mixed design process. Now, how do we estimate the required sampling thickness? Because you are going to make a mixed design and you have to collect some samples from field and take it to the lab and then do your mixed design. Now, how do you do it? I'm just giving you a simple example. There will be a couple of examples like this as in the following sections as well. So let us say, imagine that we have an existing pavement that is of thickness 20 centimeters. Bituminous layer thickness is 20 centimeters. Width of the pavement is 3.75 and I'm proposing to widen it to 5.5. Now, FDR requirement, normally what we do is 5.5 if it is the carriage way thickness, we give an extension of around 75 or 7.5 centimeters on both sides, which means that the total width of the base is going to be 5.65 meters. Thickness of the base that I'm planning to make is about 25 centimeters. Now, if you look at this figure right here, I'm just focusing only on the bituminous materials part in this example. The base and other layers I have not accounted for because it becomes more complicated. In a short presentation, it will be very difficult to for people to think through. So I'm just working on the bituminous material layer. And originally I had a layer which is about 20 centimeter thick, and I'm going to take the same quantity of material and I'm going to spread it across 5.65 meters. The given quantity of material now is spread across 5.65 meters. Now, what happens there? If compacted and after this, then thickness of bituminous layer alone, how much is that going to be? Now, if I take 3.5 meter width thickness, which is of thickness 3.5 meter, 75 meter wide pavement section with a thickness of 0.75, and I divide it across 5.65 meters, then instead of 20 centimeters, I'll end up having a layer. Even if I take that layer and recompact it to 5.65, I'll end up having a layer which has a thickness of 13.3 meters, 13.3 centimeters. Not 20, it's only going to be 13.3 centimeters. Hence, in sampling, if I do, that is what I'm going to do in my construction. Now, in my sampling, if I go ahead and use a vertical cut or a trench and I collect the entire depth of that bituminous layer in there and use it for my mixed design, the quantity of bituminous layer in my mixed design is going to be very different from what I end up having in the field when I'm constructing it. So because of that, when you are sampling for gradation analysis or for mixed design, the thickness of HMA that needs to be selected should not be 20 centimeters, but instead should only be 13.3 centimeters. Now, the subgrade soil thickness in that case, considering that the total FDR thickness is 0.25, the subgrade that needs to be, or the base and the remaining materials underneath, the thickness of that needs to be collected comes out to be 11.7 centimeters. Now, significance of mixed design. Why is everybody saying that mixed design is something that is very critical? You have to account for that. So the simple reason is that we are not constructing a flexible layer. We are not constructing a rigid layer. This is something that is in between, a semi-rigid kind of layer, which means you end up having to be in a certain bracket window in terms of your strength and durability requirements. So that is where the challenge is. If you add more cement, the strength will go up. And as a result of that, you end up having a material which is of very high strength, and as a result, there might be other problems like shrinkage and crackings and all those things that happen. Now, if the cement content is different or the strength is very low, then you may essentially having a very section that has got a poor load carrying capacity. So the technique of a mixed design is actually to maintain certain level of strength, but not too high or not too low. That is where the challenge comes in, considering that there are materials that are going into this particular work has got a lot of variability in it, like what I have mentioned earlier, the big bars, the size differences, all those things. So that is what makes the mixed design a challenging task, and that is why we have to find that optimum cement content for that particular mix which we are going to be using in that field, which means the mix cannot change and the cement content cannot change. Or if you are an additive that you are adding, like a chemical additive that you are adding along with cement, that also cannot change. So that is the challenge that you have in terms of mixed design. Now, how to do that? Sampling, again, typical practice is that you take one sample out of every kilometer. That is a typical practice. Now, we prefer to have open trenches, excavation, and then you collect your samples out of that. That brings in more homogeneity in terms of the samples that you are collecting. You can choose multiple options. Either it can be depending on the road that you actually see. If it is damaged along the outer wheel path, then it's good to have a sample collected there and something outside of that as well, so that the uniformity is maintained as you go along in terms of your sampling. Now, along with making trench pits for collecting samples, it is always a good practice. It's always a good practice to have multiple trenches. Even though you don't use it for sample collection, you dig multiple trenches and make sure that the sections that you have collected upfront, a priori, where you have sampled your materials, the consistency of the sections remain the same as we go along. So just cut it open and measure the thicknesses and make sure that there is no change with respect to the one that you have collected your sample. Now, the other thing is that it's related to the information on maintenance history and construction history, which is something, as we all know, is very difficult for any agency to maintain, and practically you will not get much out of it. So the only option that you are remaining with is to try and do your own exploration in terms of like trial pits and everything, and collect your own samples and make sure that you are getting a representative one when you are doing your mixed design. In terms of sampling, few things to remember: visual observation, that is very key. Distress identification. Drainage issues is a very easy thing that can be visually identified. Uniformity of the section can also be done by using multiple pits. Now, you can determine a representative section and how many mixed designs you may have to make, considering the variability in terms of the sectional thicknesses across the length of the road. Very difficult to identify a representative section, but still it is possible in case of a, some part of it is possible during, especially drainage issues can be easily addressed by the visual inspections. Now, trial pits, representative sample is what is being done. If milling and removal is required, then additional materials is required. All can be estimated based on the trial pits that you are taking. Now, subgrade strength, soil beneath the reclaimed material, if it is whether to check, you can check whether it is of a really low load carrying capacity. If it is so, if it is like a very high clay content soil, or if its CPR value is very low, then ideally, the FDR might not be a very feasible option that you might be looking at. Then in terms of mixed design, ideally speaking, about 175 to 200 kilograms might be an approximate number that can fit in all the test methods and processes that are involved in mixed designs. This is about the quantity that needs to be sampled. Now, critical parameters for success: meeting gradation of mixed design and field. Now, capturing the variability in the field by making proper sampling. These two can actually go a long way in terms of defining the success of any given FDR project. Mixed design, again, I believe that you all have a good idea about this, which is not very much a part of this presentation, but I'll just broadly brush through it. Now, normally what we do is we select 3 different cement. Let's say you have a sample that you've collected from field. You select 3 different cement percentages, ideally around 4%, 5%, 6%. That is a typical number. It can change, but that's a good approx estimation. Now, once you have 3 different cement that is there, every if you're let us say if you're adding an additive like a chemical additive. There are lots out there in market. So you are introducing that additive also. So for every given cement percentage, you are going to vary the additive content in that. It depends on agencies. Somebody might be using very small quantities. Somebody might be using high quantities. Let us say somebody the company's recommendation is 4%. So ideally what you do is you have a fixed cement, one of the cement percentages, let us say 4% cement you are taking. You do 3.5%, 4%, 4.5% additive into each one of those. In that one particular cement content, you vary the additive content, and then you go ahead and determine the OMC and MDD of that pulverized sample. You do the exercise for all the three different cement percentages. Again, the additive content would be recommended or rather suggested by the manufacturer of that particular admixture, and you have to believe with that in terms of your mix design. Now, once the OMC and MDD is done, then you take your sample, add your cement, and then you cure it for 7 days. Then you're going to go back and check at the compressive strength. Compressive strength ideally can be done using cubes or cylindrical samples. Then minimum of 3 numbers is recommended. That's some bare minimum that is recommended. Now, in terms of cylindrical samples, correction factors may be applied, because ideally recommended one is a cube. So if you are using a cylinder instead, there is going to be a difference in the strength. So the correction factor is going to be added, which is there in most of the codes, depending on the size of the cylinders that you are actually preparing. Now you prepare a same material, you prepare your flexural strength beams as well. Then in terms of requirements, compressive strength requirement 7 days, approximately 4.5 megapascals. And depending upon, if you look at the focus on the graph, you have varying cement contents along, and you have the compressive strength. Depending upon increase, let's say as an example, ideal case scenario, cement content increases, the strength increases, and you identify the cement content that corresponds to that 4.5 MPa strength requirement that is needed for your FDR material, 7-day compressive strength. And this comes out to be around 4.8% of cement or something like that. So that is how you estimate your cement requirement for a particular mix that you're working with. Now, next comes durability. Durability is done by multiple test methods. One is by wet and dry method, then the other one is freeze-thaw method. So depending upon which location that you are working with, let's say if you are working in down south where there is no possibility of any snow formation or cold temperature, a good test method would be wet and dry method. Now, wet and dry method is effective more or less in most part of India, but if you encounter some place like Kashmir or somewhere there is going to be problem related to frost or absolutely extremely cold temperatures, then the other method, which is the freeze-thaw method, should also be applicable in that particular case. Details, of course, are given in IRC 89. You can always go back and refer to that. Now, let's say, for example, if you get a cement strength right, or the strength right by using a cement content, but durability it is failing. So in that case, what you have to do is you have to repeat the whole experiment by modifying the cement content and doing the same exercise again. Now, durability test is typically done not in all the different cement proportions. The one that you get, which is your ideal mix, wherein you found the optimum cement content, that mix only needs to be tested for your durability. So because you are finalizing that cement content and you are just checking if durability criteria are met for that, also met for that particular mix. Now, in terms of pre-construction, if I move a little bit further, now there are a couple of things. There are going to be data that is going to be available. This before the start of your construction work. You are going to be available. You're going to have multiple data sources in your site itself, which is the lab reports that has been prepared as a part of mix design, the soil survey reports that has been developed as a part of initial DPR preparation, then the mix designs that has been developed. Make sure that you're familiar with all these things even before the construction work starts. Now, along with that, before stabilization being done, you need to make sure that you do a visual inspection of all the locations so that any subgrade issues, water-related, drainage-related issues can be identified a priori. Utility structure utility facilities identification can also be done as a part of the initial preparation. Now, in terms of equipments, you're going to be using a reclaimer. So the cutting edge of those reclaimer is a carbide based cutting edge. You need to make sure that it is working fine. In case of water, the water is going to be sprayed on top of the surface before mixing. So the sprays and nozzle, are they working right? The disbursement of water, is it as per what is being shown on the monitors inside of the vehicle? All these things needs to be checked. Then comes the cement. If the cement is being spread uniformly, is it going in lumps, or is it kind of spread across uniformly? The quantity that of cement that is going onto the surface, is it accurate? All those things need to be checked out. Graders. Now, if the graders is working, if the cross slope that you are going to be making is based on the effectiveness of the grader, so is it working properly or not? That also needs to be checked. Now, pre-construction, one of the earlier steps that you have to do is to identify the finished road level. That becomes very important because you need to know what exactly is going to be the finished level. I'm just going through the same example that I have given earlier on that. The thickness is about 0.2 centimeters, 3.5 meter road widened to 5.5, and the total width of the base comes out to be 5.65. Now here the thickness of your base is 0.25 or 25 centimeters, and let us assume that the existing road level is 101.30 meters. This is the reduced level of the existing road. Now, same case, if compacted after, if I am taking 3.75 and spreading it across to 5.5, if I compact it like that, like what we have seen in the earlier case, the compacted thickness would be somewhere around 13.3 centimeters. Now, what happens because of that? There is going to be a reduction in the level, top level of your road surface. Now, originally it was 20 centimeters. Now it has gone down to 0.113. So there is a difference of about 6.7 centimeters. Now, in terms of reduced level, originally it was 101.3. Now it has gone down by 6.7 centimeters. Now the finished level of top of the FDR base after construction would be 101.233. On top of your FDR, you are going to add a SAMI layer, which carries about 6 millimeter thickness. And on top of that, you have a 40 mm BC on top. So if you're wanting to estimate the finished road level, is going to be the reduced top level of your FDR, which is 101.23 plus the thickness of your SAMI layer plus the thickness of your BC. So the final finished level after construction would be somewhere around 101.28 meters. That is what the final level would be. Now, the next thing is how to estimate cement spread. Now you are actually doing a mix design where you will be given a weight percentage in terms of, let's say you have to, for a given mix, you have to add 5% of cement in that mix. Now that is a volumetric or a weight based estimation which cannot be done in field. You are actually going to have to spread the cement laterally, horizontally, and it can only be estimated based on area. So volume has got to be translated to area when you are estimating the cement spread that is required. Again, the same set of examples. Same set of numbers that I have used earlier. Width again is 5.65 meters and thickness of the FDR is 0.25. Now, let's assume that the as per JMF, the cement content is 4%. Now, the quantity of FDR, let us assume that we have a 5.65 meter wide newly built FDR section, and if I go 1 meter forward in terms of length, and if I go for about 0.25 centimeters depth, and I'm going to estimate the quantity of that material in there. So it's basic multiplication, and it gives me that the total quantity is going to be about 1.412 cubic meters. Now, how much quantity? How much is that weight of this quantity going to be? So if I take the approximate the density of this FDR mix to be around 2000 kilograms per cubic meter, then I have a total cubic meters and I have the weight per cubic meter, which means that 1.4 multiplied by 2.86 ton is going to be the weight of that section, which is 5.6 meter wide, 1 meter long, and 0.25 centimeters depth. The weight of that section would be about 2.83 tons. Now, based on weight, from my mix design, I have a number. So if I have 2.6 ton, 2.826 tons of material, and if I want to add 4% of cement into that, simple multiplication will give you in terms of how much cement is needed in by weight, which is going to be around 0.113 tons or 113 kilograms need to go on a road which is 5.6 meter wide, 1 meter long, and about 0.25 meters deep. Now, estimating the spread of the cement, Now you have 113 kilograms of cement, which needs to be spread across 5.65 meter width and 1 meter length. So making appropriate calculations, you can get that rate of spread of cement should be around 20 kilograms per square meter of that roadway. If I take 20 kilograms of cement and spread it across per square meters, then I would end up getting a mix which has got about 4% in terms of weight percentages. Now, spreading of additives, that's another thing. There are two ways in which additive comes, one as a dry powder or as a wet powder. If it is a dry powder, it's a pretty simple estimate because you already know the estimated amount of cement, which is about 20.01 kilograms per square meter. That is the number that we have estimated earlier in the earlier slide. Now, the additive requirement, the chemical additive or chemical additive that you are adding along with cement, the requirement that is being set is 3% of the cement content. Now you have a area-wise distribution of cement, which is 20.1 multiplied by 30% or 3% of that, which gives me the dry powder spread is going to be 0.6 kilograms per square meter that I'm working on. Now, if you are introducing that as a liquid, the calculations slightly gets modified. The cement content, again, I'm retaining with what is there, 20.1 kilogram per square meter. Additive concentration, let's say in this case, is 2% of cement content. Now, the additive that is required is 20 kilograms, 20 multiplied by 0.2, which is going to be 0.4 kilograms per square meter. Now, the challenge here comes in is that the additive, the liquid additive, is not added directly onto the soil, which means I'm not going to add 0.04 kilograms per square meter onto the surface of my pulverized material, or rather before pulverizing, I'm not going to add it directly onto the surface. Reason is that if I do it, the quantity is so small that you won't end up getting that additive to go into every single layer or the entire depth of your FDR material. There might be a huge concentration on the top, there'll be nothing at the bottom. So you need to have something that can dilute it, spread it across the entire mix, and that way you have a uniform mix when you are working on it. So the easiest way to do that is to mix it with water and then add it along with along at the time of pulverization, and then the presence of this additive is going to be uniform across the depth of your FDR material. Now, how can I estimate the proportions that I need to mix? First, let's say the OMC, as per JMF, the optimum moisture content is 11%. Now, that is based on lab studies. Now, in field, the soil already has got some amount of moisture in there. Let us say the in situ moisture, natural moisture content is 4%. So if I'm going to have an optimum moisture content, I need 11% in there, but out of that 4% is already there in the site. So the water that I need to add during pulverization and mixing is 11 minus 4, which is coming out to be about 7%. Now, if I consider that some amount of this is going to be lost in evaporation and during the construction process and all, so I can add about 1% extra, which makes that mixing water required for pulverization is now about 8%. So I have assumed that the density of the mix to be 2000 kilograms per MQ. Now, the weight of FDR, if I try to calculate that for every square meter, I have 1 meter width, 1 meter length, and about 0.25 centimeter depth. And the unit weight of that is around 2000 kilograms, which means that for a square meter, the depth, the thickness of the weight of the FDR is going to be approximately 500 kilograms. Now, the weight of water that needs to be added per square meter, we know that I have to add 8% water. So I have to add 8% of water by weight. And the weight of the material that I have is about 500 kilograms. So the net quantity of water that needs to be added is 500 multiplied by 0.08, which is 40 kilograms per square meter, or in other words, 40 liters per square meter. Now, the additive requirement is earlier estimated as 0.4 kilograms per square meters. Now you have 0.4 kilograms of additive required per square meter. Along with that, you have 40 liters of water per square meter that needs to go in. So how much additive needs to be estimated per liter of water? That is 0.4 by 40, which is about 0.01 kilograms per liter. Now, if I take that in a larger estimate, the quantity that requires to go into a truck, which is the easiest way to do that, which is how it is being done in the field. You have a 4,000 liter truck that you're using. Now, the requirement is 0.01 kilogram per liter multiplied by the total volume of water or the weight of water, which is 400 liters. So if I have a 4,000 liter truck, I need to add 40 kilograms of my liquid additive so that I can get a 2% quantity of additives on the distribute that 2% quantity additives into the entire depth of my FDR material. So that is how you estimate the proportioning of the liquid additive that needs to be there. Now, after doing all the mix designs, after making adjustments and getting to know how these things needs to be mixed, what really matters is whether we are able to replicate a mix design onto my field. Simplest thing. I mean, it has got to work in the field, otherwise everything is useless. Now, I cannot take a risk in terms of constructing 5 kilometers and check if the processes work fine or not. Now, an easier solution to address that problem is to build a trial patch, which is something that has been done in all UP projects. Every single project had a trial patch. Trial patch is nothing but a 100-meter stretch of a road, 100-meter stretch of the exact same road that I'm planning to do the FDR work on. I take that 100 meters, I bring in all the machineries that is going to be working in the entire stretch. The exact same machinery will be there. The procedures that I'm going to follow for the exact road is going to be replicated in that trial patch itself. And I'm going to do the FDR process for that particular length. Now, this can help in certain ways simply because if you're trying to achieve a density, your rolling pattern is going to have a significant influence of that. You can take this as a trial example. This trial patch is a example patch where you can play with the rolling patterns and try to see if the density has been achieved or not. So it can help you immensely when you are doing the remaining 5.5, 6.5 kilometers that you have to finish. So all these things can be estimated by doing the construction of a trial patch. So everything remains the same: materials, machinery, the processes involved, all needs to be according to what is going to be done in the remaining section. So that is what we are trying in a trial patch. Once you are done the trial patch, you come back and do your quality checks on that particular section. Like say, for example, the field, you dig out the cores, get the compressive strength of those cores and see if it is meeting. Then you do the flexural strength. Flexural strength is in the form of, done in the form of beams, which cannot be cut out of the field. So what we do is we take the samples prepared from field. After this pulverization process during the exact same machinery, we collect the material, we compact it in the field lab itself and make our beams out of it. And we do the particular curing that is required and do the testing after that. Then comes durability. Again, done on field course. There are 12 cycles of wetting and drying test that needs to be done. Details are available in specifications. You can always refer to that. And after completion of durability, you check the residual strength after durability testing. So this is a pictorial presentation of how durability is checked. It's a wire brush method where you have the sample that is subjected to different conditions, of course. And after that, you take a wire brush and apply a standard pressure on this sample and try to see how much of a material is actually coming out of that particular sample in every cycle. And now you have X amount coming up in cycle 1, Y amount in cycle 2, and so on. At the end of 12 cycles, you look at the total amount of weight loss that has happened, and that amount of weight loss should be within certain acceptable limits. That is how this method actually works. Now, once you have this durability checks done for 12 cycles, you take that sample that is left over, and then you do your compressive strength to find the residual strength of your samples. Again, compressive strength testing, and I think everybody knows how it is being done. So this is an example of something that is done in UP as a part of the FDR initiatives. Cores were cut down by using field core cutting machines. The cores are cut out after 7 days and after 28 days from the trial patch, of course. And again, they are sent for various laboratory testings that we have actually mentioned in the previous slide. Then this is the presentation of that sample that has been collected from this particular location. Now, testing done, then what is the next step? It is acceptance, whether it is meeting the required criteria or not. Now, in terms of UCS, the requirement criteria is 7 days. The strength should be somewhere around, should not be less than, I would say, 4.5 megapascals. And after 28 days, the strength should be somewhere of the order of 7 megapascals. Again, 7 megapascals is something, 7 MPa is something that is it's a slightly, I mean, it is anything between, I would say anything between 7 to 8 should be something that 7, 8, 8.5 at best would be something that I would be okay with. Because beyond that, if you increase the strength, again, this is still under deliberation, and the code recommendation is 7 megapascals. So you have to stick with it, but anything up to like 8 or so should not be that big a problem in terms of shrinkage cracking issue. That is again based on personal experiences, but follow the codes if that is the requirement. So just keeping in your mind that it cannot be that big a problem in that case. Now, in terms of durability, you have 12 cycles that you're performing. The maximum weight loss that is allowed is 14%. If you have an intact sample to begin with, and you do all the durability test, at the end of the day, you lost about 15%. That means that durability test failed. If you have the particle loss is 13%, the sample is good. Now, the residual strength, it should not be less than 20% of the 28-day strength. You have an original sample that you have tested at 28 days. You have a strength number, say for example, about 7.5 megapascals. And after durability test, once you do the compression strength, it should not be less than 20% of 7.5, which is about 1.5 megapascals. If it is above 1.5 megapascals, residual strength is okay. Now, in terms of flexure, the flexural strength should not be more than 20% of the 28-day strength. Yeah, again, 28-day strength you measure based on your cylinders, and flexural strength you measure by beams, but 28-day strength cannot be more than 20% of the 28-day strength, which comes out to be 1.4 megapascals. Again, there are a few deliberations that is happening in terms of this number as well, but as of now, this is what the norm is. Now, once this thing is, once you get the results of your checks on your material, then the result of the UCS, flexural strength, residual strength, they are examined and they are recommended. Now, only once the numbers that is obtained here is accepted by the concerned agency or the client, then only the contractor is allowed to proceed with the main work. The advantage that you have here is that, let us say if the strength is not meeting, the checks that you do in terms of the cement content, all those things, we will discuss about that later. It could be an issue with the cement content that is being there, put in there, the spreading of the cement, it's not uniform. So the sampling you have done in a certain location where the cement quantity was less, and it ended up having a lower strength when compared to what is required. That could be a possibility. Mixing is not proper. The mixing was not proper because the reclaimer had some problems. That is one issue that you can have. Then the other thing is that the rolling compaction, the shift foot rollers, the other rollers that you have been using, they did not perform well. The rolling patterns that you have set as a part of your initial process, that is not right. So that could also end up you having a strength requirements less than what is actually mandated. So all these things, trial patches give you an opportunity to make sure that it is working fine. So for every project, it's a very good practice to have a trial patch introduced in the beginning of the work. Only problem is that constructing a trial patch and getting a clearance, that will require some time around 2 months. So that's why the timeline that I've already mentioned or the distribution of work that I mentioned earlier comes into picture. Let's say a contractor has about 5 or 6 works in the near vicinity, and he does the trial patch in one section. And when by the time the 60 days are over, he can actually, in between then and the 60 days, he can actually go to the next site and do the trial patch there, and then circulate among the available sections. So by the time the whole trial patches are done, then he'll be in a position to start working on that first project that he has worked. So the machinery is not kept idle during that entire process. So that is where the planning part of things comes into picture. Now, construction in terms of some good practices, ideally speaking, cement starts setting in about 2 hours. So the compaction has got to be done within 2 hours. OMC quantity and accounting for NMC, OMC quantity has got to be according to what the mix design is recommending. Curing moisture has got to be ensured. Then profiles and cross slopes, everything needs to be checked, and they should be according to as per requirement. Then visual inspection, again, we have mentioned that earlier. Now, in terms of checks, Pulverized material gradation, if it's meeting the mix design, that is one check that you have to do as a part of the construction process. Then moisture content corrections, if required, you can do that in the trial patch itself. And also that needs to be monitored for every step of your construction, because climatic conditions change and the NMC keeps on changing. So the moisture content requirements keeps fluctuating, and that needs to be accounted in every step. Then comes in cement application rate and spread, that we will talk in the next slide. Then in terms of mixing, the uniformity or consistency of your mix, that you have to check. How to do that, we will talk about in the following slides. Now, compaction, ideally we try to reach about 98% of the maximum dry density, ideally speaking. Then compaction time, like I've mentioned, it's about 2 hours between mixing and final compaction. For curing, multiple ways are being used. Certain cases by addition of water as a curing agent, or in certain cases people try to use moisture sealant so that whatever water has gone in during the mixing process does not go out. So sealants can also be used. And strength gain, again, strength requirements we have discussed earlier. So in terms of post quality checks, post construction quality checks. Now, project success is defined by multiple factors, especially the depth of FDR process, then the uniformity of your pulverization, the cement content, moisture content, all these things factor in. So pulverization is something that can easily be checked based on the gradation that you have. Pulverized material sieve analysis can be done in site as a part of quality check, and make sure that it is conforming with the mix design requirements. On-field corrections if required, if they are not met, then one of the main problem that is happening there is because the reclaimer is the speed of the reclaimer. If it goes very fast, mixing is not going to be finer. So you will end up having larger size particles in there, which is not a good thing. That can affect your gradation. So the cutting edge of the reclaimer that you are using, it is worn out. Because of that, also the mixing cannot, or the gradation can be inappropriate. Cement application, how to check it? One easiest way is to use a 1 meter square canvas. You spread the canvas on the road where cement is being spread. Let the cement spreader run through it. And once it is done, you come back, collect that sample, and weigh out exactly how much cement has fallen in. Now, the alternate way that people try to use is to use empty trucks, or you load up a certain quantity of cement onto a truck, and then by the time the distance that is taken, that it takes for that cement to finish, that is taken as a criteria, and based on that, the area of spread is estimated, or the spread is estimated. Again, this is not a very accurate way of doing it, simply because the quantity will remain the same even if it's a uniform spread, or if they dump a higher quantity on one place and a lower quantity on the other side. So that is always possible if you are doing it that way. So ideally, square canvas, using a square canvas or a canvas for capturing the cement is the best way to do this, to do the spread estimate. Now, next thing is moisture content estimation. How can we do that? It can be done in field by microwave oven, or by simply heating the soil sample to a higher temperature and finding out the moisture loss that is incurred during the heating process. The direct way of doing it. Nuclear gauges can also do it, but it's less accurate. Now, there is a simple and easy test, that is an approximate test, which is known as a hand squeeze moisture test method. Again, fairly well accepted. See, the thing is very simple, and once you have the mixing and pulverization done, if you take the sample in your palm of your hand and then you just squeeze it. Now, once you open your hand, if the soil samples actually falls apart, just like soil, it just falls apart, what you can estimate is that you have not reached the OMC level. Now, if you squeeze your hand and you open it, now the sample remains intact, just like what you are seeing here. Then you can fairly well estimate that, okay, you are very near to the optimum moisture content. Now, the third case, if you squeeze the sample in your hand, the sample remains intact, but when you open your hand, your palm is wet, which means that there is more moisture than what is actually required, which means you are exceeded the optimum moisture content of that particular mixture. So that's a very quick and approximate method, but it is very effective in practical senses. Now, uniformity of mixing is something that you have to check. This is done basically based on what is known as a phenolphthalein test. Phenolphthalein is a chemical that is, is being used in this process. This can be done two ways, either on the cores or the core openings. Basically, what you do is you have a core opening here. You let the phenolphthalein drop through the depth of the core cut, and try to look at the color changes. Phenolphthalein gives a pinkish red color when it interacts with lime-based additives. So if the color of this, the phenolphthalein is uniform all the way across, like what you're seeing here, then it means that the mixing or the cement present is uniform across the depth of your section. Now, if there is some different coloration somewhere in between, which means that the cement content is either high or either low. So that is a reflection of improper mixing. This can be done in the using the core cut openings, or it can be done using the cores itself. You can just strip the phenolphthalein along the edges. Now, if it is not meeting, then you have to make necessary adjustments. Now, other thing is that density checks. There are a couple of ways in which in-situ density can be checked. One is a nuclear gauge, which is a calibrated nuclear gauge you can use, or a standard method that is typically practiced, which is a sand replacement method. Now, if there is a significant difference from mixed design, or if you see that there is a significant change in the gradation that you are getting as a part of this process, moisture density relationship has got to be rechecked. That becomes very important at that stage. Now, field cores, collecting field cores that can be used for different reasons. One is again, in order to check the depth of the FDR layer that you have constructed. So has it really gone to 25 centimeters, or it has a little bit less than that? That can be identified based on field cores taken immediately after construction. Then you can check the cores to see if there is any irregularities, there are soft spots or anything like that in the sample, which indicates that the compaction is not proper. Now, one thing to remember is that the compressive strength of these samples are not recommended. Even if you take this sample, cure it for 7 days and do a construction compressive strength test, it's not a valid result. Simple reason is that when you are immediately after construction, the FDR layer has got minimal strength. So when you run a core cutting machine, the sample will actually get disturbed, and there is a good chance that you will not end up having the required strength that is needed. Now, quality control testings again depends on the frequency, depends on various agencies. It can vary anywhere from, this is just what the NRRDA guidelines recommend, pulverization about 1 in 250 meters, then cement application rate every 500 meters, then all the other associated tests as per the guidelines. This is done in accordance to what the specification says and in presence of the engineer, of course. Now, one thing keep in mind is that once you construct the FDR layer, it is always better not to leave the FDR exposed for a longer period of time. That means that you either have to stop the vehicles moving on it, or as early as possible you have to cover it up with a overlay. Again, this is also, there are a couple of suggestions that we have made, and it is I believe it is still under process. They are evaluating those suggestions and try to, right now the process is that only PC can be laid only after final test and durability tests are completed. But we have suggested something else which might possibly be there if it is accepted in the revised guidelines that is given. The problem here is that FDR has good strength, but the frictional force, or rather the traction because of the wheels, the abrasive forces created by moving vehicles, that can actually disturb the road surface. So if you leave it open, the surface can get damaged, and you need to have to do some corrective measures before laying the final BC layer. That is a disadvantage, and it can also accumulate some amount of damage because of that. I have 3 or 4 slides which I'm just going to briefly go through, which is not related to, so the completion of this presentation. One is that SAMI layer, it has got certain specifications in terms of material that needs to be used. The properties like it should be resistant to chemical attacks, routing and everything. It should not be torn across. The SAMI layer should have a certain minimum strength requirements in terms of tensile strength, elongation. Again, most of these are based on guidelines, and again, the manufacturer is the one who is going to be responsible for making sure that the material is of the required quantity, and so has got to be the engineer by testing it. Base preparation before laying the surfacing layers. the layer has got to be cleaned either by a mechanized broom, and all the irregularities and dust and everything needs to be cleared out by using air compressor or by blowing air over it. And once it is done, then the next step would be spraying of a primer coat, which is typically an SS1 emulsion that you are going to be using. And the rate of spread is approximately around 0.9 to 1.2 kilograms per square meters, again as per specification, of course. Once the prime coat is done, you should give it proper time for it to cure or to break, and only after that the next layer can be put on top of it. Now, on top of the priming coat, you have to apply a tack coat, which is again based on can be done by using a spray bar, and typically a VG10 grade bitumen is being used in as a tack coat, and the application rate is around 1 kilogram per square meter, again based on specifications. Now, once the tack coat is laid, then the next step is to put in the SAMI layer on top of that. Just make sure that there are no wrinkling or folding of that SAMI layer when you are placing it, and on top of it, in order to ensure that there is proper bonding between the SAMI and the underlying FDR layer, of course through the tack coat that is present, PTR rolling is done. Then on top of the SAMI layer, next step is going to be placing of a tack coat on top of it, again at the rate of 0.25 to 0.3 kilograms per square meter, that is the rate. And RS1 grade emulsion is typically what is being used in the tack coat on top of the SAMI layer. Now, the final step after all these things is laying of the bituminous layer, and once the SAMI layer has been put in, the tack coat has been applied on top of it, then bitumen is placed on it, and the excess paving fabric that is there beyond the edge of the pavement is trimmed off and removed. Again, these are all as per guidelines that is recommended for usage of these individual materials. And with that, I know it has been a bit longer than what was expected. I'm done with my presentation here.
Thank you, Shyam sir, for the detailed explanation. Now let us quickly move on to the panel discussion. The moderator for today's panel discussion is Dr. Anil R. from College of Engineering, Trivandrum. We also have with us panel members, Engineer Sandeep KG, Chief Engineer LID and EW Kerala. We have Engineer Anil Kumar RS, Chief Engineer PMGSY Kerala. We also have with us Dr. Chandrasekhar, Research and South India Business Development Head and FDR Technology. We also have Engineer Brijesh Dubey, State Quality Control PMGSY UP. And most importantly, we have with us Veeraraghavan sir, Guru Vittal sir, and many other experts. I strongly believe that they will also join the discussion. We also have a couple of questions in the question bank. Maybe we will discuss it after that. Now over to Anil sir for further discussion.
Good evening, all. Good evening, Dr. Shyam. It was an excellent presentation and extensive, very good presentation. My co-panel members, Mr. Sandeep sir from LSCD, CE LSCD, Mr. Anil Kumar sir, CE PMGSY, Dr. Chandrasekhar and Technologies, and Professor Veeraraghavan sir and Guru Vittal sir. So, Sandeep, Shyam has already explained a lot about the FDR technologies. Especially, he has put a lot of input on the challenges in FDR construction. So I think that has been to be discussed today, because these challenges may be experienced by our engineers in PMGSY, those who are now doing this experiments now in PMGSY routes, as well as he has already explained about the FDR quality and the mixed design procedures, as well as the quality aspects on that and the sampling methods. So it was excellent presentations. So I think it is already being late, so we start the panel discussion. I had a request that Mr. Anil Kumar, engineer, that KSRDA has to leave. So I just start with Engineer Anil Kumar. So can you please put your comments or your experience?
Thank you, sir. Sir, I am Anil Kumar RS, Chief Engineer of Kerala, now in charge of PMGSY road, sir. Very excellent presentation, sir. And I had executed agreement for 300 kilometers recently for PMGSY road, sir. and we had started the program. And now around 10 kilometers of FDR works has already completed. And the results are very satisfactory results. And the program is now going well. Sir, one doubt is that whether there is any relevant IS codes for, specific for this FDR works. And another doubt is that if there is a rocky layer below the subgrade within 1 meter depth, and we are constructing a semi-rigid FDR layer, there is a sandwiched layer of soil between the rigid rocky layer and the semi-rigid FDR layer. If the modulus of subgrade reaction of the soil is low, whether there is any problem of compressibility of the soil and the failure of the FDR layers. That is has to be clarified, sir. Thank you, sir.
I think Professor Viragavan is there.
Guru Vital is there. I think Guru Vital is the right person to answer. Finally, I will come in case if necessary. Guru can answer this question easily.
Oh, okay, sir. Regarding the first question, there are no IS codes for this FDR process because FDR is a FDR is a actually IRC is in the process of making the code. It is under discussion. HSS committee, it was presented, and maybe it will now come up in the council. So very soon you will get the FDR code from the IRC. There are international codes are there. FHWA code is there. So the of course until we have this IRC code, we can refer to the international codes. Regarding your second question, that some rocky layer is there below the subgrade soil or below the subsoil. Actually, this would be a kind of a tricky and a typical problem not encountered everywhere. Maybe in a particular stretch of land, where a particular stretch of road where you may be having, maybe in the hilly area, I believe. Actually, there one or two issues which will be important would be the drainage issue. Are you having any drainage problems there? If you are having a drainage problem there, then the seepage water is there, a rocky layer is there, you are going for an FDR layer, then we'll have to be careful. Otherwise, if there is no drainage issues in that particular location, I don't think it would be a problematic area. This is my answer. Thank you.
Thank you, sir. Thank you.
I also agree with what Guru Vital has mentioned. If there is a soil cushion, subgrade soil of 500 millimeter above the rocky strata, then there are no issues. If you can compact well, I think there should not be any issue, even when constructing the FDR over a rocky strata.
Thank you, sir. Thank you, sir.
Sir, any other question? Anil sir, any other question?
No, sir. Thank you, sir.
Okay, sir. Thank you. Now we request Professor Veeravan sir to open his comments.
No, that's a good presentation. I think we have been working with Shyam for long. We have visited several sections in UP, so we know the issues, but there are few challenges which we are trying to solve in the new guidelines. I also shared the new draft guidelines with Shyam, requesting him to share his thoughts on that. The issue which everyone is asking, I think I would like Shyam to respond is that he has shown a table wherein different soils, the possible stabilizer that may be added. As Shyam has mentioned very wisely, cement / an additive. So the $1 million question which everyone is asking in this group as well is that, what is the magic with the stabilizer is playing? Is it necessary to add the stabilizer along with the cement? Or will cement alone be adequate to meet the requirements of strength, durability, residual strength, as well as the performance? I think I request Shyam to respond to this. What are his views on the requirement of stabilizers? Commercial chemical stabilizers.
Professor Viragavan, this is one area that has been in discussion for a very long time. As in different presentation. I think you were also there in some of those. So this is a valid question that has been asked across. And if I share my kind of experience in terms of working on this similar projects outside of India, of course, you cannot say that it's absolutely necessary, because we have worked with sections where only cement was used. And furthermore, you also have to add that there has not been many studies, or rather comparative studies, in terms of effectiveness, how effective these stabilizers are, or these additives are. As in, like, no data is available on that in terms of their performance, because FDR as such is still in the nascent stage in this country. Hardly 2 years or so has passed. And the performance evaluation of mixes with and without stabilizers, that would be what is required to make an estimate on how significant this additive is. And unfortunately, that data is not available. So based on what I have seen here in India, now everybody is using these kind of additives, but it is possible that I would say that it can be done even without.
Exactly. That's exactly what I wanted. I expected to hear from you. Yeah. I think there are some few questions. We can respond to those questions that, because the participants are interested to know, get a response to their questions.
Sir, I'll add on to that question, sir. Shyam, when we are doing it, FDR on PMGSY old PMGSY roads, they have a crust thickness of granular layer maybe around 250, 300 millimeter will be there. And on top of that, you have 20 or 40 thick bituminous layer is also there. In that kind of road, there will not be any chance of getting the soil into that or the subgrade into that. In that case, do we need to go for a additive, or simply that cement will work?
Ideally, it should work. That is what I was saying. But again, considering that it is widely recommended across the country, I mean, you can try that with a trial patch at least. For all these projects that Kerala is actually encountering, a part of the trial patch can be done without. Not everything, because the contractor also is very familiar in terms of like using those additives, or he's wanting to use that additive. Why don't we just take a chance on, say, 50 meters out of that 100 and do that section without adding any stabilizers and see if it is performing the same way or not. And if you have multiple trial patches that we have done, and then we have enough data to actually validate this thought, or rather the experience that I have had before, and that could be a good way of moving forward.
But in case of a Panchayat road, that will be different. Maybe sometimes you will get 100 or 150 alone. The rest will be soil will be there. So that will be different for Panchayat roads. But in PMGSY roads, the scenario will be different.
Okay. So your question was whether, sorry, did I go away from...
No. In the first case, only granular is coming, then there is no need of additive, right? Or we have to check.
No, granular, you should ideally be getting the strength that is required.
Case, if you are getting more soil or the subgrade is coming, then we have to think about or do some design.
That is what I was saying, that if we have multiple sections that we all are working on, every section is going to be different. Okay. Now, if we have a small patch in every section, let us just not jump into conclusions at this time, because ministry also recommends using additives. That is a plain and simple thing. So let us not jump into conclusions saying that this is what we think it is correct. We can do these small patches wherein sections without any additives has been prepared, and let us just compare their performance with respect to the other, how different they are. If the additive one is performing much better than the cement one alone, then obviously there is a case that is there. If not, then end result is very clear in paper, in data.
Okay, so the variability is the challenge, I think, right?
Variability in terms of materials.
Yes.
Of course,
composition.
It's a challenging thing. We will have to check that based on these trial patches, just to make sure, in a very possible way, that what we are getting is consistent, less variability of material.
Okay, thank you.
Anil, there are a number of questions.
Yes, I will read out, sir. I will read out.
Yeah.
Mr. Avani Chopra, so please give your viewpoint on how can we ensure that after implementation, FDR will perform better than newly laid flexible payment in terms of performance and durability.
This has been time tested around the world. There's nothing new. Definitely, what we are now talking is about reusing the material that's already there so that we can reduce the virgin aggregate consumption. Any stabilized, improved material is likely to perform better than a deteriorated payment. That's why we are recommending an FDR.
Thank you very much, sir. Actually, this is Abhi this side. Sir, I need to know one thing that I think my other two questions were answered. It is related to the age and quality of the old pavement. How does it affect the job mix formula for the design of FDR? So, what is the correlation amongst the age and quality of the old pavement?
You are asking about
yes,
the age.
payment age and how we can connect it with the design, like the job mix formula, whatever we have, as you showed a few calculations. So will it be, in accordance with the age, any relation that it has?
Actually, if I understand the question, no, it is not. Because we have a multi-layered structure, which is a pavement, of course, with a bituminous layer on top and granular layers underneath that. Now, bituminous layer interaction or bonding with cement per se is not going to be that good when compared to the other. So, with respect to age, thing that I can expect is that as we progress in age, there will be more distresses. So there might be a possibility that there is going to be more overlays that is put on that road, which means that the quantity of this bituminous material is going to be higher in that case. So then it becomes a matter that needs to be looked up. Other than that, if it is the same section, same thickness, the granular layer or the bituminous layer has age of that layer has limited thing to do in terms of achieving the required strength properties.
Thank you very much, sir. Thank you. It was a wonderful presentation. Thoroughly had a good, knowledge and the interaction, the panel discussion, a very good concept. Thank you.
Thank you. Thank you very much.
So Shiju Chandran also have a similar question. What I have seen is about 50% of granular line and 50% subgrade. Normally seen milled. Chemical additives are also added in addition to cement. What exactly the chemical additives do? Is there any method to quantify the effect of chemical additives in FDR layer?
I think that question was answered as a part of the first discussion with Professor Veeraraghavan and Professor Vittal. So if there, I think these are on the same lines. Again, I will reiterate. Yes, people are recommending the use of it, but a comparative study on effectiveness, whether yes or no question, a comparative study, we don't have enough data to validate that which one is better or is it really doing something or not. We don't have it. So we may have to come up with some ways in which comparison can be done with additives and without additives. And then only a conclusive response or rather a recommendation can be given on this particular topic.
Next, I have a doubt. FDR technology can be adopted till what design traffic? Another question.
The MSA level, low volume roads is what is typically suggested for the MSA levels. I think it is 10 MSA or so. I don't, maybe Dubeji can confirm, but the technology has been recently implemented in high volume roads as well. Some of the NH development projects are actually using this FDR technology, which CTB primarily, but FDR I think is also being used in some in Kerala, if I remember those. Maybe Professor Veeraraghavan can explain that locations better.
Sir, I think we'll move on to the panel members. Sandeep sir. Sir, can you share your views? Sandeep sir, Chief Engineer LSTD.
I think it's not there.
Shall we move on to Dr. Chandrasekhar and technologies?
Sir, good evening to everyone. Wonderful presentation by Shyam Nair sir. And sir has explained every corner of the problems rightly manner. So we are about 3 works we have taken, we have completed in Kottayam district, and with Oralangal we are doing 1 work, so that it is likely performing well. I mean, we are doing in a right manner, and as well when the traffic is open, so there will be some chipping as Shyam Nair's presentation. So the department, I'm requesting department people to understand that it's the nature. When we are allowing the traffic, obviously there will be 1 mm or 2 mm chipping may happen. Okay, so try to consider that it is not a structural failure. It's due to vehicle movement. With that, there is another issues related to utility shifting all. When it is a expensive machinery and all, so that definitely we need to take care of utility shifting before commencing the work. So that is also one observation what we made when we are doing with PMJSY roads. So all other things, the presentation has covered everything. Thank you very much for the opportunity.
I think
Thank you, Dr. Chandrasekhar.
8%, Mr. Chancellor, you're right answer. It's the question, what is this stabilizer doing in FDR? Could you please tell what ant stabilizer is doing? Yeah.
Definitely, sir. So same thing. Every presentation we are discussing. So definitely, we are very assured that there will be a better performance is there with the cement and with the cement along with additive. So the same thing we have observed in laboratory and as well as in field sections. So personally, we have conducted. So that is there is a strength related and a durability related, and as well as early strength to achieve the early strength. In these 3 areas, so the additives are working along with cement.
Yeah, Anil, go ahead.
Thank you, sir.
Yeah, thank you. Anil? Yeah.
Okay, thank you.
Yeah.
Next question. One second. How FDR affect the bearing capacity? I think by Abhilash. I think Abhilash, what actually meant by this? We'll go to the next question. Why do we have to wait for 60 days for a trial batch when we have strength result in 28 days? By Chiranjeevi.
Well, it is not only strength that is put in as a part of evaluation. One is the strength, then the other one is the durability, which is something that is very significant in terms of ensuring long-term performance of this material. So durability test, like I have mentioned, is a 12-cycle test, and every cycle, if I remember correctly, it takes somewhere around 40 to 60 hours every cycle. 12. I mean, I think somewhere around 2 days is what every cycle is, which means that 12 cycles is 24, and 28 days of curing time. The test is conducted on a 28-day cured sample. So 28 days of curing, then 24 or so days of durability testing, plus a few days in terms of testing and other reporting and all those things. So ultimately, it comes out to be around 50 plus 55 approximately a number of days for the entire set of testing to be completed. Again, the Thing is, it is not just compressive strength. The durability also plays a key role, and the residual strength after durability, which means that if the road has been to various climatic conditions, then will it be holding enough strength? Residual strength measurement is actually checking. So that is also important in order to ensure the long-term performance of a pavement. So that is why it takes near about 2 months to complete the entire strength of testings.
I request UPRRDA Brijesh sir to open his comments.
Good evening. Thank you. Thank you for giving me chance. I would like to, because presentation was excellent, I would like to add few things. One, because execution is a totally controlled execution. So for that, requirement of the manpower, it has to be highly skilled. As mentioned by Professor, the movement of reclaimer, speed, OMC, NMC, everything has to be checked. And then only the desired requirement of the pulverization will be achieved. This is one. Number two, there was a question regarding the availability of the crust. What I am saying on the basis of the experience in UP, wherever there is a crust more than requirement, we have provided soil or earth, or we can say fines, above the granular materials, and we have tried to keep the ratio 30 to 70% fines and granular, and vice versa. Somewhere we have got a very less granular material. They are also, if it is less or no granular material, like if the road connectivity has extended up to school or something, there is no granular material, only earth is there. So we have given at least 30-35% of the granular material like GSP, etc. Otherwise, in UP, most of the places we have less than 25. Third point, as mentioned by Professor Viraraghavan sir also, see what we have done in the field. It was sanctioned by NIRDA for PMJ works. So we could not do the research and testing part with additive and without additive. Definitely, it has to be examined by the research institutions. And if without additive we can achieve something, so we can go for it. But so far we have executed more than 4,000 kilometers of the FDR, and we are nearing to complete our project within 3 months. So I can say additive will give some thing for making it to semi-rigid. The additive companies, they have to act upon it, and we have, for that, those controls which were mentioned by the professor, we have tried to keep it here. Contractor as well as additive persons in picture, and their technical persons in the field, because whatever is there, they have to manage from doses, from the quality, from the spreading, everything. So in UP, we have executed accordingly. One more thing which is we are facing problem, that is gradation. In most of the places, we are not able to achieve the set gradation which have been mentioned here. Most of the places, it is not, even at 53, we are getting 65 or 70% passing, or retained by 35, 40. And second thing, UCS value. See, taking out core and getting it checked. If for every meter or 2 meter or within 10 meter, the UCS value is changing. It is changing because taking out core is also an art. If machine is very good, it's smooth, no vibration, then the result will be different. If it will be slightly low cost machine, the result will be different. Yes, we have achieved 4.5 to 7, but in few cases we have achieved UCS above 7, and at in few roads at certain changes, it is even more than 10. So these, why I am quoting here, giving details here, because Kerala is going to execute and executing it. You also try to do the same thing and just confirm whether it will match with our result or not, because soil and everything will be different, but the other thing and results of the FDR layer should be approximately matching. So that's all from my side. Thank you.
Thank you, Brajesh sir, for sharing your experiences. Especially, I think UP has done extensive work on FDR. I think around 4,000 kilometers you already completed, right?
Yeah.
Okay, sir. Shyam, Dr. Shyam, another question is regarding the sample dimension of UCS and durability test. Aren't we following IRC SP 89 and 120, IRC 120?
Regarding sample sizes.
Sample dimension of UCS and durability test, aren't we following IRC SP 89?
Yeah, the specimen size is as per IRC 89. And 4-inch diameter cores for 4-inch diameter cores and 15 centimeter cubes.
Okay, what about the importance of flexural strength test? Is it really required?
It is required, yes, because the higher the flexural strength is, the reflection cracking possibilities goes up, and we want to avoid, because higher flexural strength, higher flexural properties can lead to reflection cracking. Of course, that is why that is considered as a significant.
Amrita has raised this question. Now coming to Pradap Mohanty, can we use FDR in high volume roads? What type of cement we can use?
Well, the type of cement actually does not, I mean, you have to do the mixed design, and type 1 cement is generally recommended, because this is less, I mean, pozzolanic cement, if you add, the strength gain is going to be much slower. So type 1 cement is typically preferred for the usage. Brand, again, you'll have to check out based on the mixed design things, and whatever is being available, that needs to be looked upon. And
Pradap,
what was
Pradap, you raised a hand. Do you want to
Yes,
add
sir.
something?
Yes, sir.
Okay.
Am I audible,
Okay.
sir?
Yeah. Please.
Sir, thank you very much, sir. During the presentation, what we noticed that during the FDR process, we are also going up to the subgrade level. Certain thickness of the subgrade, we are also utilizing for the FDR. So, what is the use of drainage layer, sir? In case of FDR, do we need really to have a drainage layer? Do we have to leave some GSB or something below? Or FDR itself will be able to manage without drainage, especially in PMJSY roads?
the drainage that I was referring to was not on-road drainage. It's a surface drainage, as in like drains.
I'm talking of the GSB, which is usually serving the purpose of drainage.
Yes.
So when we are going for a depth, when the GSB is already taken into the FDR, as well as certain portion of the subgrade also, you said sometimes 5 centimeter, 10 centimeter subgrade is also taken into FDR. So the FDR will not be left with any drainage layer.
Okay, now I got your question. Yeah. So basically, if you look at the permeability, or rather permeability of these layers, FDR has a very low permeability. So water coming up from the bottom to capillary rise, the chance of that getting onto the top layers is very less once you have this FDR layer in there. So even though it is not a drainage layer per se, but the water coming from the bottom cannot, it's very difficult for it to propagate through the FDR and get to the top layer. But the problem will come in if the water is coming from top, which means that it can come in from the top and affect the permanent performance. So that is why drainage layers above, which is the surface drainage features, becomes a key aspect of this FDR construction. At least not even depending on financial resources, of course. Sometimes, going for a concrete drain or a brick drain is going to be difficult because that can add up to the cost of construction. So even an earthen drain, which can, easily remove the surface water falling on the road surface, that would take care of things. But I will not be too much concerned about the GSB level gone and water permeating from the bottom. That will not be much of a problem.
That's not a problem, sir. This is a similar answer we have given. But many people there, like engineers, they are telling as per the IRC, we have to give a drainage layer. If not 200 mm, 150 or 170 mm, drainage layer is required. So they are getting little like bound by the codal provisions.
Actually, so FDR does not carry a code at this point. Like Professor Vittal was saying, that if you have listened to that, the IRC is just now trying to introduce a fresh code for FDR, and NRRDA is a specification. The yellow book, the orange book rather, is one of the guidelines that is has got references to international as well in terms of coming up with those guidelines. That's the book of practice, at least for majority of the PMGSY roads that is being used right now. Of course, there are references to IRC specifications, say for example 89 in that particular code. So none of them actually, now if you think about it in a slightly different way, how are you going to, because it's an in situ process and you are going to mix up the materials and try to add an additive, and you are going to get the product that you're looking for. Now, if you want to add an additional layer, first thing that you have to do is to move all these materials to the side, place a fresh drainage layer, then put it back again, and then do the whole process, which is practically not going to be a it's not going to be a practical solution. And again, coming back to the question that you have asked, no, requirement for a drainage layer is not mandatory in this case.
Sir, in Kerala, we are already doing this technology. We are already using it there, sir, in NH. So already NHI has permitted 10%, 20% like that. So there we are not only doing FDR, we are also doing stabilization. There also we are getting materials from outside, the Murom and other things. There only the case of drainage layer is coming up.
Not exactly CTB, I mean FDR that you are talking about. It's more like a CTB work.
Yes,
where everything
CTB.
is fresh material and you are basically working on, the existing ground itself.
Yes, sir.
So then you're using a layer of just a normal construction that you are doing. Sir. So at that point, yes, introducing a drainage layer underneath the stabilized layer, that makes sense if it's a waterlogged area. But ideally, if you ask me, then I don't say that it is a mandatory, absolutely mandatory requirement. But maybe Professor Veeraraghavan is there. He can further comment on this particular topic.
We had this interesting question again and again from Bihar. I think Guru Vittal, can you tell this? We also had discussed a lot about this GSB layer requirement in FDR. Guru, can you tell?
Okay, sir. Actually, this requirement of GSB, especially in this PMGSY roads, if you see that in none of these PMGSY roads, the GSB layer is daylighted. It ends within the embankment. So how exactly the drainage is going to happen? It's a big question mark. Since year 2000, we have been building so many PMGSY roads, and none of these roads are we have the GSB layer to be dilated. That condition is not there. That's the first thing you have to notice. The second thing is that the drainage requirement becomes critical, not everywhere, But in a high rainfall area, especially of course in Kerala, it may be and if it is an lower rainfall area, I don't know. I don't think this daylighting and this requirement of drainage layer, etc. All those may not be count too much. That's second point. Third point is that if you look at this IRCSP 89, they give so many different combination of this pavement cross sections which can be constructed using this cement treated base and cement treated sub base. So in that the provision for this drainage layer at different locations they have indicated, and some of the cross sections which they have indicated, they are even without drainage layer also. So that's why as Professor Sham was telling, in the FDR construction, we may not need this particular drainage layer requirement, and that can be overcome because basically the FDR layer is impermeable in nature. Thank you.
That's a very valid question. The only point which Mr. Mohanty is asking is that this layer is likely to crack. We know very well that FDR layer will crack. Similarly, the bituminous layer also may develop cracks, potholes, higher air voids. So some water will get in through the cracks in the FDR layer. If so, the subgrade may get saturated. Perhaps a good surface drainage, as Shyam was mentioning, will enable running of the surface water and very less water can penetrate. Therefore, the requirement of a GSP may not be required in the case of FDR layers.
Thank you, sir. Thank you very much, sir. Before I leave the last question, sir, this is a very senior professor here. Sir, is there any study going on in composite layer, like combining a FDR or stabilized layer with a cement layer on the side, rigid? Like we are having a semi-rigid layer of FDR or stabilization. Over that, if you are going to lay a rigid pavement, will it help us in reducing the thickness of the rigid pavement, sir? Is there any study going on this, sir? Combining two layers instead of providing a GSV, DLC, over that we go for a rigid layer. So in case we are, instead of GSV, DLC, we are going for a stabilization, whether it is soil stabilization or FDR, over that we lay a rigid pavement. Will the combination work together, sir, by any chance, sir?
It will definitely work. It will definitely work because you are reusing the material. It will function similar to that of a DLC. You need not provide another DLC layer. The old pavement material can be built and laid as a FDR, over which you can construct your cement concrete pavement. There will be a savings in aggregates, materials, cost, and definitely an improved performance. Definitely, it can be considered. There are no issues as far as construction is concerned.
Thank you, sir.
So I think research work can be proceeded in that side also.
Sure. Yeah.
Okay. Now I think Narasimha Rao has raised his hands. Can you just give your comments,
yeah,
Mr. Narasimha?
Yeah. Good evening, sir. Thank you. It's a very good presentation, sir. I'm a retired superintendent engineer in Andhra Pradesh Panchayat Raj Engineering Department, and at present working as a project advisor to a project, AP Rural Roads project funded by Asian Bank. I want to add one point, sir. Somebody was asking whether flexural strength has to be evaluated for this. I want to add one point in this regard, because FDR is a semi-rigid layer. In rural roads, we are adopted IRC 62 for rigid pavement layer. Previously, rigid pavements were designed for compressive strength, based on compressive strength, but right now, in the present code, we are designing rigid pavements as per IRC 62 for 90 days flexural strength. That is why I think the answer that since this is a semi-rigid layer, the flexural strength is it is required. That's what I want to add, sir. Thank you.
Sir,
was I audible? I have spoken.
Yeah, it's audible.
Sir, I think I have made my point, sir. I just added something. Somebody is asked whether flexural strength is required for assessment of this FDR layer. That's why I added this point, sir. Thank you.
Dr. Shyam? Mic is mute, I think. Mic is mute.
Yes, Professor. Yeah. Hello?
Hey, it's audible.
Audible, sir. You're audible, sir.
So was there a question or I didn't, I don't.
No, sir, I added.
It was an explanation that.
No, I added a point, sir. I added something. I added just.
Okay.
I am not
adding.
I added for somebody else
Yeah,
to query whether flexural strength was to be evaluated for this layer. That's what I have added based on my experience for rigid payment design based on SP62, where flexural strength is required, is a grading factor for design of rigid payments. Since this is a semi-rigid payment, that's why it is also necessary to take flexural strength into consideration. That's what I added.
Okay. Okay, right. Now, another question. I want to know if there is any project related to FDR with emulsified mixes you came across. Dr. Shyam, have any experience on emulsified mixes?
No, I have not worked with.
Anil has carried out. Anil, you should be able to tell what you have done with emulsified.
But actually, we are just only in a very preliminary stage only. We are not started, sir.
Yeah, there are two methods by which we can do this cold in-place recycling. Either you can use a foam bitumen or you can use an emulsion. I think in Kerala, I think the studies are in progress. The general performance has been found to be good. Either you can use emulsion. The advantage is that it will not crack like this FDR layer. Only there can be rutting. I think it's time that some academic institutions take up the studies on emulsified base courses, or using foam bitumen. Studies have already been carried out. They are performing much better than any other granular layers. So both can be adopted as a cold mixes, as a good base or a binder course.
Okay, thank you, sir. From Ashik Asad, the questions are: is the maintenance strategy adopted for the FDR road is in line with that of the conventional FDR FP? Also, any specific changes for maintenance being considered for the new IRC code on FDR?
We are only currently evaluating the performance here by different academic institutions. I think as far as I am concerned, I do not think that there will be any change in the maintenance practices. There can be a cracking, there can be a pothole. So these things are the conventional maintenance strategies. With a good binder course or base course, these payments are likely to last longer with a lower maintenance requirement. I don't think anything new will be there. At the most, there can be cracks on a like a stabilized basis. Perhaps these cracks can be attended to by any other conventional method of maintenance.
Okay, sir.
Thank you, sir.
Mr. Srijit, I think he has raised hand.
Yes, sir.
Please.
Yeah, Shyam sir, thanks for that excellent presentation. My doubt was regarding the role of the fabric there. Now, I understand it is used as a crack relief layer. So on a long-term sustainability angle, I was thinking, what about the recyclability of all these roads that's being constructed? Thousands of kilometers of roads are being constructed. Why can't we go with a seal coat as a CRL layer, just a normal seal coat, instead of going for a fabric? Because anyway, we are not in the design part. I don't know whether we are including considering any modulus improvement factor or anything like that. But just had a doubt regarding the sustainability part and the recyclability of this fabric.
Actually, the use of seal coat may not be very effective option in terms of stopping the propagation of cracks onto the bituminous layer. It is thickness is less than something like a what do you call it? I forgot names. Chip seal kind of an option, where you have a bituminous layer and aggregate spread on top of it. So that might
Yeah.
come in handy in that. But again, when you are using bituminous materials as a crack layer, then a crack leaf layer, then the costing has got to be other thing that you have to look at. So again, there are options, but typically preferred one nowadays, at least in India, is the geomembrane that we are using. So obviously, ease of construction, a lot of other things are there. So though all these things actually effectiveness is also there. So all these things have contributed to that being used as a preferred choice for this crack leaf layer. Now, in terms of recyclability of this FDR layer, yes, of course, it is possible. I remember that I have mentioned that I mean, if you have a geotextile in there, it is not recyclable, right? Now, in this case, if you look at it, the geotextile is being added hardly at about 5 centimeters from the top surface. So a simple milling option can remove this top layer effectively, and all these material that is being, instead of using a reclaimer to remove that, a simple milling option can be able to, I mean, this is just my thought. I'm not giving an answer. It is a practical thing. Please understand that. So this recycling is just starting. You are asking about recycling. So it is a long way ahead. I mean, 10, 15 years ahead. So I don't think that would be that much of a problem, because a milling option can remove this HMA layer and the geogrid geofiber or geotextile that is there, and milling operation can itself break it down completely. Then the question comes in, is that going to be effective if it gets reused along with the existing material, along with the FDR that is being recycled? Now, that is a little difficult question, because the geotextile is a different material altogether when compared to bitumen or the granular layer or the FDR layer underneath. So introducing that milled out section back into the FDR when you are trying to recycle the FDR is something that cannot be answered right away. Possibly we might have to look at the feasibility of that by doing a few simple, experimental studies, and then only that effectiveness can be effectiveness of reutilizing the milled HMA layer can be addressed. I hope I answered the question.
Yeah, thanks. Yeah, thanks.
I think Mr. Srijit is asking for an alternate material other than this one. That is,
that is what I was wondering, because even if you go for a milling as well, from my experience, it may not be easy if there is some sort of a unless it is a glass grid, even if you are milling an interlayer or an asphalt layer, unless it's a glass grid type of reinforcement, it may not be easy. It will just it will just get into these these teeths, even for a milling machine. So that was my concern, because the thing is, kilometers are being constructed now, and I don't know what will happen in the future. That was my doubt. I was thinking that same way, the type of seal where you spread the bitumen and then you spread the aggregates, type of DBST or SBST. So I was thinking of that alternative, whether it would work.
So that it will be compatible, right, with the
chip seals are going to be effective, but only problem that can come in is that, see, chip seal on top of it, if you use a larger size gradation material, say for example something like I don't know, I mean DBM or something, where the maximum aggregate size is of the order of 20 centimeters, and you have something of a similar size or even less size material that is there on top of this chip seal. Like I'm putting a bituminous layer and I am spreading aggregates. IRC based, what is the chip seal? I forgot. Chip seal is a US convention.
Surface dressing.
Surface
dressing, yes.
If you are using a surface dressing, then you are using a fine sized aggregate particle on top of it. Now, if you are using a larger size bitumen layer on top of it, which means that bitumen layer is not going to go too much into your surface dressing, which means there is going to be an opening in between the two, which can basically act as a crack relief, because the cracks cannot propagate through because of the voids inside. If you are using that kind of a layer underneath a BC, wherein the fine aggregate particle size is much smaller, which is equivalent to or even less than the chip seal size that we are using, then the cracks actually gets filled up by these finer materials. Now, if that is the case, then the cracks can have a pathway through which it can propagate upwards, which means the effectiveness can actually go down if we are putting it directly underneath the BC and putting a BC layer on top. That's what my thought is. I mean,
understand. So in that case, it will act more or less like the OTA seal, so something like the OTA seal of the South African. Okay, anyway, that, yeah.
Again, it is just a thought. I mean, it's not a critical answer that I'm saying, but just a thought.
Yeah. Amrita, do you have?
Sir, yes, actually, yes, sir, yes. Thank you for the presentation, sir. Actually, I also had this doubt regarding the SAMI layer in case of its sustainability or recyclability. It's already solved. Sir, I have this doubt regarding the structural design part for the FDR layer. Sir, are we considering this SAMI layer or this CRL for structural design as well?
Amrita, no, this is only a functional layer to retard the cracking. It is not considered as a structural layer in the design.
Okay, sir. Okay. Sir, regarding, I'm speaking totally about the rural roads. Regarding the CBR value, can we conduct a DCP test for collecting the CBR value, determination of CBR value inside?
I think Shyam has already showed about that. There are some correlations between the DCP value and the CBR. However, the value will not be equivalent to the soaked CBR that you consider for the design. So consider that factor as well when you use the DCP to estimate the CBR.
Okay, sir. Okay.
So I think I forgot to include that in that slide. Yes, no.
Sir, we have a lot more questions. Shall I read, or those who are here can raise their question, or shall I read? Sir,
sir, one more question, sir.
Go ahead.
Okay. Sir, regarding the sample specimens, I have asked a question earlier. The question was actually, I have saw a specimen, hand size cylindrical specimen for durability. We are having typically above 50 mm particles in the ground. So is it possible to handle that kind of samples in this small specimen, or do we have to go for larger specimen dimension?
You're right. You're very right. 150 millimeter diameter cores are required, not the 100 millimeter diameter cores.
Yes, sir. Yes, yes. So I could see that small specimen. That's why I'm asking. That's all. Thank you,
You're
sir.
right. Yeah.
Okay, another question from Vivek. If the layers of existing pavement are overstressed and there is rutting in the surface, in that case, FDR is workable by using the same material. I think it's a statement as he has mentioned.
You're not clear. I don't know what is that mentioned.
Sai Chiranjeevi, Mr. Chiranjeevi. Can you hear, Mr. Chiranjeevi?
Hello, sir. Hello, sir.
Yeah.
Sir, thank you for the presentation. But actually, I just wanted to share one view, sir, which we have experimented one thing, sir, in Mysore, Karnataka. What we have did is on soil stabilization, we have gone for the SS1, and above that layer we have spread the microsurfacing layer of 8 mm. Hello.
Okay, then what? So what?
No, sir. No, sir. Actually, I was saying that actually it has been a successful, sir. I think it has been more
any
than a year. So,
any emulsified base will be better than a granular base. Instead of having a thin layer, you have used a microsurfacing. That's it, right?
Sir, instead of SAMI layer, can we use as a microsurfacing layer, sir?
I don't think that will function. Okay. Because function of the SAMI layer is different from that of the microsurfacing.
Okay, sir. Okay, sir. Okay. Thank you, sir. Thank
you. Another question. In QA and QC for cohesion test, the wire brush is used to check the with some pressure. In figure, it was done with hand. How to ensure the pressure applied is same when other person has done the same test?
Actually, there are some methods that are mentioned in that guideline itself by using a kind of, it's a crude way of doing it, but if you take a weigh balance and apply some pressure using that wire brush and say check for the readings, that might give you a feel exactly of what kind of a pressure needs to be applied. So that you can use similar pressure fields and try to brush the materials out when you are doing the test. And if I recollect correctly, there are also some machineries that has been made which can do this on a a controlled fashion. I have seen it somewhere, but I'm not very I could not recollect where exactly it was. Was it here, abroad, or not? I don't recollect. But this is a crude way that is being mentioned in one of those codes, that how to perform this wire brushing. Again, the point is very relevant. It is subject even though it is mentioned, the results are subjected to human variability factor, because the technician who is performing on it, that is there. But these are the guidelines, that broad guidelines that can be followed in this case.
I think much difference will not come, I think.
And again, it
depends, right? Okay.
Yeah, it depends. I mean, but if you do this kind of, even though crude, if you do that, then it might be able to eliminate a good percentage of errors. That may come in during this experiment. But that automated wire brushing unit, I have seen it somewhere, but could not recollect where it was.
I think CRRI has it.
No, not sure. Maybe Professor Vittal can confirm that.
Okay. Okay, fine. Next question is from Praveen Kumar. In FDR technology, do we lay only 130 mm to 40 mm thick BC layer as wearing course?
Yes.
Will the addition of a base bituminous layer DMBM increase the life of the pavement when compared with a single BC layer as a bituminous wearing course?
Of course, you are looking at, if you are adding a DBM on top of it, the service life or the load carrying capacity is definitely, you are adding structural value to the road. So now the question is, it depends on the design. I mean, you are looking for a specific
based on the traffic, right?
Traffic, yes. Based on how much of MSAs you are expecting within a span of your FDR, which is, I would say, about 8 to 10 years is a reasonable span for a FDR layer that you are putting in. Sometimes it can go even more, I agree. But if the road is actually going to be able to cater, say, 6 or 7 MSA, then there is no need. Now, if it is you're expecting something much bigger than that, yes, the structural value that is required for that road is going to be higher, and you may have to think about options like DBMs or something else along with the BC surfacing.
I think similar question again, when the road gets upgraded to a higher category of road with increased traffic, then how to go ahead with the building of the crust to take care of enhanced traffic only. Traffic flow conditions already been explained.
Yeah, same.
The infiltration of water from the shoulder portion of the carriageway could be considered in heavy rainfall areas. Will the absence of drainage layer at the bottom of 50R could lead to saturated subgrade, leading to associated issue? I think also we already mentioned that, right?
Yeah, again, we have mentioned that, yes.
How do we gauge the seepage water coming out from the ground in a hilly region?
How do
we gauge the seepage water coming out from the ground in hilly region?
Well, I mean, seepage
based on the geometrics, right?
Huh?
Based on the geometrics, what is asking in hilly region?
Now, this has to be seen as a case-to-case basis.
Yeah.
Maybe the capillary cutoff may have to be provided, or the level has to be raised depending upon the location. A general answer response cannot be given for this question.
Okay. Sir, in this CAR, CCPR with emulsion or formed between mostly recycled aggregate will be used. RAP is generally a stiffer material, then why we need to consider or study the rutting of these kind of mixes?
So these cold in-place recycled mixes or the bituminous replaced materials have got high voids when compared to dense bituminous mixes. Voids as high as 10% or more. Therefore, these layers are likely to rut. Perhaps if you carry out some experiments, you will know it better.
Okay. So another question from Sundar: since the FDR is impermeable, what would be the effect of surface water during rainy season, influencing the moisture content of the berms that would in turn influence the moisture content in FDR?
So we have hard shoulders in many cases. The water will penetrate down. I do not think this is an impermeable layer. I don't think there will be any effect of the moisture content on the FDR.
Yeah. So the questions are over, sir.
You can thank
So
Shyam for his time.
I thank Dr. Shyam Nair for his wonderful presentation and for the discussion. I thank Dr. Veeravan sir also and all the panel members, especially Guru Vittal sir and other panel members. I thank all of them. Over to the organizers. Thank you all.
Thank you, Prasanna. Thank you.
Thank you.
Thank you, everyone. Thank you, Professor Veeravan.
Thank you, sir.
Thank you, sir.
Thank you. Thank you all.
Thank you all.
Thank you. Thank you.
Thank you so much, sir, for the wonderful and nice presentation. You have been presenting continuously for more than 2 years. Shyam, sir, thank you very much. Thank you, sir.
Thank you. Thank you.
Thank you, Dr. Shyam. Thank you, sir, Veeravan sir. Thank you.
Yeah, thank you. Yeah.
Thank you all. We can close the session now. Thank you.